All right, got my coffee. We can jump into it. Okay, so yesterday we learned TDD with Mocha. And today we still have one project left on TDD Mocha, and we'll jump into server testing with TDD. And also some advanced testing concepts. We should be able to finish this today, maybe. We'll see. We'll see how it goes. It's dead. All right, so in this project, you will use test-driven development to build a factorial method. You will use the assert module and Mocha testing library to drive your development using tests that follow the phases setup, exercise, and verification. So, how to calculate factorial? You take an integral and multiply that by all the integers that are less than it. The factorial of an integer n is denoted by an exclamation mark and exclamation. So 5 exclamation equals 5, 4, 3 times 2 times 1 equals 120. Edge cases. An edge case is a problem or a situation that occurs only at an extreme, maximum, or minimum operating parameter. You can think of these special cases. Doggy sleep. Yes, doggy sleep in the doorway. You can think of these as special cases that you need to account for. Based on the logic of factorials, you would expect that calculating 0 would look like 0 times 0 equals 0. But mathematically, that's not true. In this instance of a factorial method, there's an edge case which is that 0 factorial is 1. Okay. The steps below follow the red-green factor cycle and will guide you through the process of using test-driven development to create a factorial method. The factorial method will be inside an object named calculate. You will be implementing your test code in the index.test.js and your implementation code in index.js. After you complete each step, run the test suite in the terminal to test the results. Okay. So, in your test.js file, add an it statement and then fill in the error message to state that it will test if the output of 5 factorial is equal to 120. Okay. So testing if 5 factorial is equal to 120. Right, the syntax is, we don't need these parentheses here. We do a comma, then parentheses, then this. And then this. Yeah. Okay, so follow the steps below to write a test that checks if 120 is equal to calculate factorial 5. Write an assert equal statement inside your it block. The first argument in your assert equal statement should be calculate factorial 5. The second argument should be 120. All right, so assert equal, and we do calculate dot factorial 5 and 120. Yeah, so this should return test. Yeah, this is failing because we don't have a calculate.factorial function. We do have an object. So add a factorial method inside the calculate object. It should accept one input and return 120. So factorial number and returns 120. Okay, let's save this, run npm test again, and we pass. All right. Now we have to refactor this. So setup will look something like result equals 120. Const result 120. Const let's do, instead of result, like expected result. And then actual result. I'm still trying to think of like variable names that would make the most sense to use for these two variables. Expected result, actual result. Calculate dot factorial of 5. So this is our setup phase. Well, actually, this is our setup phase. This is our exercise phase. And then we just we just do actual result and expected result. And this will be our verify. Okay. So everything should still work. Yes. Okay. Going into red, write another test with an input other than 5 to put yourself back into red. This will force you to write implementation code that covers more conditions than just factorial 5. Okay. Let's copy this, paste it here. If factorial, say 6, no, 3 is equal to 6. So the expected result is 6, and the exercise passes in 3. All right. So this should fail us. Yeah. Got 120. We were expecting a 6. In your index, replace the line of code, return 20 with code that will actually calculate the factorial of the input argument passed into the factorial method. Okay, so we can do reduce with this, right? Or actually, we can do just a for loop for let number. No. No, we can do it. For let number of but we can't do a range. Okay, let I equals 0. So while I is less than, oh, we need to do it backwards. So number, while I is more than 0, we want to do I minus minus. So this will start counting the thing. I also want to do like total. So while that is happening, we want to do total times equals number. Right? And then we just return total. We got a 0. How come we got a 0? Oh, because, right. Number minus 1, maybe? And we start total at number. $5,120. And here we got 24. I think we did one too many. Slow brain being slow. Wait a sec. So I starts at, say, 3, right? I starts at 3. Oh, we do I, maybe? No, still 0. Wait, I starts at 3. the total number, so 3 times 2. Then I becomes 2. Ah. Well, I is greater than, what if we do 1? Multiplication by 0 turns everything to 0. Yeah. Yeah, okay. Now it works. Okay. If you haven't already done so, make sure that all your test code uses descriptive variables instead of actual numeric values. And make sure that it follows the first 3 phases of a good test. Refactor your implementation code so that it is more concise and efficient. This could include cleaning up the existing code or using built-in method instead of a for loop, or calculating the factorial of any input. But I don't want to do it. I don't want to do it. I feel like it's fine. It's just a singular for loop. Yeah, we're fine. So, edge cases. Write an empty it block with an error message that covers the 0 edge case. Okay. Testing if 0 factorial is equal to 1. Expected result is 1, and this is 0. So this should fail the test. Yes. Okay. Well, we can simply do if number is equal to 0, just return 1. I think that's the simplest approach here. Save this, run the test. Yep, everything still passes. Bum, 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 bum. Finish writing your edge case test unit. I did. So that's it? Okay. Let's write a couple more tests. See if everything passes. Do like 1, 2, 3, 4, 5. So we have 120 to 6 to 1 factorial. I don't really have the brain power today to do actual calculations, so let me just see. All right, so factorial 6 should return 720. Factorial 6 should return 720. And 6. No, That's 720. That is 6. All right, this one next. Let's do 13. Should return this. 13 is equal to this. 13. Excuse me. Codecademy. Thank you. It didn't save, did it? Oh, it did. Okay. That's fine. This one. Let's do an even bigger number. Let's do 16. Should return 20 trillion? 16. 16. Okay, let's make something more simple. 7. Factorial 7 is equal to 5,000. 5,000. 7. And the last one, what can we do here? 1? Sure. Factorial 1 is equal to 1. Expected result 1, and this is 1. All right, let's save that, see if it passes everything. NPM test. It did. Okay, that's pretty cool, actually. Like, it does force you to write, like, to not get out of hand, not to overwrite your code, I guess. All right, that was easy. All right, server testing stack. Let me take a sip of coffee. It's sufficiently cool enough. Nothing better than a cold coffee in a cold morning. Did I say cold coffee? It's not that cold. Pretty warm. Okay. When testing an application, feature tests expose required tests or implementations at different levels of the application technology stack. One of those levels is the backend server. Server tests are used to test the server response only, not any front-end rendering of code or user interactions. We disconnect the browser and interact directly with the server using requests. The tests define the expected behavior of the interactions and check the actual responses against what we expect. Server tests are commonly used to test API responses, but we also use server tests for any server response that our application relies on. This can include checking status codes and error messages. In this lesson, we introduce a suite of technologies and concepts for performing testing on a JavaScript-based server. These include Chai, JSTOM, and Supertest. We also review how to async await or asynchronous calls. When adapting this to your project, it needs to be tailored to match the specific technology stack for your project. All right, seems complicated. Hopefully it won't be. In the pane to the right, user visits root test is pre-populated with feature test code. Run the test by typing nps test into terminal. When you're ready to move on, check your work. Okay, let's take a look. All right, so save the message with the author information has failed. Expected clauses to include feature tests often hit every level of the TDD testing pyramid. All right. Don't know what any of this means, but sure. What is it with yawning? Where I don't know if it's just me, but whenever I yawn, I feel the need to just scream my lungs out. There was actually a meme about it saying that that's how men release their inner anguish or something. All right, so the test is currently failing. The test is attempting to verify that a message is being saved, but this behavior is not implemented by the server yet. This guides us to implement the code for a desired behavior. So, when writing tests, sometimes you'll find that the tests require calculation steps or inline code to determine if the test is passing. For example, to test if an array includes an element bar using Mocha with the built-in node assertion library, we use the JavaScript includes helper. Oh, okay. To improve the readability and flow of our tests, we extended the built-in node assertion library with chai. Assert. Why is it an object now? But okay. Required chai. The main function in chai we're using is include. This allows us to rewrite the previous example. Assert include. So where we're looking for and what we're looking for. Okay. So include also works to check that text contains certain values. Ooh, that's actually useful. The large set of assertion methods in the chai library enable us to write more expressive tests that are easy for developers to understand. Okay. So, in the chai test to the right, we've included chai at the top of the file and set up a describe block with Mocha. Use chai on line 9 to assert that the foo array contains the number 4. All right. Assert includes, and we do foo and included number. I feel like, yeah, that should be correct. Maybe. npm test. Assert includes is not a function. What? Oh, include, not includes. Array.pop should return a value and remove the element from the array. Expected empty array to include 4. I did that. Did you use assert include to check if foo includes included number? Yes, I did. What's your problem, Codecademy? Wait, what? Why is it here? Oh, okay. Never mind. There we go. So in JavaScript, the pop method removes the final element from an array and returns it. Write an assertion to verify that variable foo_pop returned from the pop method returns the correct element from the array. So actually, let's take a look at test. It is passing. So write an assertion to verify that the variable foo_pop returned from the .pop method returns the correct element from the array. Okay, so assert equal. So foo_pop should be equal to included number. Right. Since we popped the only element from the array, foo should be empty. To check this, assert that the length of foo is now 0. Okay, so assert. Can we do assert length? Foo 0. Is this a thing? I wonder. No. Length is not a function. Okay. Assert equal foo dot length. Can we do this? Yeah. Is that how they did it? Yes, that's how they did it. Okay. All right. Testing HTML responses. Our backend server is serving dynamic HTML to the user. One second. I'm going to close the windows. It's getting a bit chilly here. Thor is all pooped out. He ran around and walked around so much yesterday. He is pooped out. Okay, for the homepage, this is located in the JS DOM tests file to the right. It is possible to use include to verify that the HTML response contains certain strings, but gets cumbersome to verify the hierarchical relationships of DOM elements. We can use the JS DOM library to improve this type of assertion. It allows us to use select elements of the DOM to check relationships and content. To increase the readability of our tests, we abstracted the JS DOM functionality into a custom function. Parse text from HTML. Okay, this function takes the HTML response as a string and the desired selector as inputs, and returns the text content of the corresponding element. No element. Jesus. If no element is found, it will return a type error. HTML as a string and then selector. Selected element, text content. Okay. In the panel to the right is pre-populated with the code to test that the string hello is contained within the HTML response. Run the test by typing npm test in the terminal to observe it pass. All right. Change the existing assertion to use parse text from HTML and assert that the string hello is contained in the hashtag bar element. The first argument should be the HTML string foo, and the second argument should be the selector. Run the test. Okay, so we just changed this into a function call. The second argument should be the selector. Okay, parse text from HTML. HTML as a string. Oh, no, we do parse text from HTML, and we pass in the first thing should be the string, which we get from foo. And the next one should be hashtag bar, right? And the second argument here should be hello. Think so? npm test. Assertion error. Expected empty clauses to include hello. HTML test bar should include the string hello. Okay. Modify the HTML string foo to include the string hello. In the bar element. Doesn't it have that? Modify the HTML string foo to include the string hello. in the bar element in addition to the buzz element. What are you talking about? Oh, like two divs here. Okay, never mind. npm test. Eh. Oh, not here. Should be here. Yep. Okay. Async wait. A server typically handles many requests at a time, but may be only capable of processing a subset of the requests concurrently. One side effect of this is that the server response time is neither instant nor predictable. If no other processes are occurring on the server, requests are handled quickly, but if the server is close to full capacity, the request can take a few seconds or even time out. We need a way to receive asynchronous responses from the server and then act on them. The async wait pattern introduced in Node 8 helps us write readable descriptions of the behavior of our application, which is an important part of writing good tests. To use this pattern, define a function with the async keyword. Then, within the function, use the wait keyword in front of the asynchronous function you're calling. For example, okay, function async console.log await return true. Okay. To the right, there is a start of a server test on the root document of our site. There are no assertions yet, but we're attempting to log the server response to the console. Run the test. Run the test as is, and note that we see an undefined response logged to the console. The request method is covered in the next exercise. Sure. npm test. It's passing the homepage. Turns the correct content. Update the function to use async in the function definition and await for the call to request. Update the function to use async. In the function definition. Which function? I mean, instead of this whole thing? Uh, a little bit confused, but get this out of here. And wait for the call to request. So request. Wait request. No, that doesn't seem correct. Are only allowed within the async functions and at the top levels of module. So outside of the test? Um, wait. Do. I don't get it. Const response. Oh, this is an async. Oh, okay. Async. And, oh, wait. Test. Hello, testing world. Okay, I don't understand this, but let's move on. As you may have noticed in the previous exercise, we're using the function request to make server calls to support our test. This is actually a reference to the supertest library. This library was specifically designed for testing node servers' responses and integrates well with Mocha and Chai. To use supertest, we pass the app object from our app into the request function. Into the request function. To make a GET request, we use GET with the desired route as the argument. Okay. It is also possible to perform a post using supertest. We chain any desired properties in our inputs to the HTTP call and use send to make the request. Post message, type form, send author message. Okay. Let's say supertest. In the panel to the right, there is the start to a server test on the root document on our site. Chain the get method at the end of the request. Pass the appropriate argument to the root object of our app. Okay, so here we do await request when we do dot get this and then dot send. No. Unexpected token dot. How you told me to write it. Dot? Oh, we should probably remove this then. We want it to work. npm test. Yeah. Okay. That was a short thing. In the pane to the right, there is a test that makes use of all the technologies. Run the test using npm test and verify it passes. The next lesson will use these concepts to further explore testing a node server. npm test. Okay. Oh, would they let thee go? Thor doesn't even bat an eye. JS DOM. In this resource, you will find the documentation and GitHub repository for JS DOM, a JavaScript implementation of various web standards such as WhatVG DOM and HTML standards for use with Node.js. This is helpful if you'd like to be able to simulate a web browser for use for testing and scraping real-world web applications. I guess we can take a look. But I feel like I need a bit more of an intro into working with a server because I don't really understand any of this. For some reason, request stuff is kind of hard to get for me. You can learn more about API testing using Supertest library. This is helpful if you want to know how to write and run tests for your endpoints. Story is entirely optional, but you can help deepen your understanding and skills of the Supertest library. Oh, no, thank you. I don't know. Lots of text. More Supertest documentation. Sure. All right, so which technology allows us to write assertions against Node.js server response? Chai? No, it's Supertest. God damn it. Why is the following test failing? Because dog name, spot, pets. Mm, I guess dog name's not contained, but no, it shouldn't be a problem. Oh wait, no, dog name is not contained within the request, within the response. Excuse me, is contained within the response, but it's not inside the correct element. Oh right, right. Okay, let's try this again. Really slow-brained today. Which technology allows us to write assertions against HTML DOM content? So it's JS DOM. Okay. What is the following code asserting? It's asserting that Codecademy contains decade. Yep. Irfan. Hello, man. What's up? Feeling kind of drained today. Kind of slow start today. The stream started a little bit late, and also I'm like sipping on coffee to wake a bit more up. but it's not having the effect as much as I would like. It's like yesterday after the stream, girlfriend came back. We ate dinner. We went outside. We went out, and while we were walking outside, we she was like scrolling something, and she noticed that like the biggest mall in my city now allows dogs inside. So since we need to sort of socialize Thor to people more, we decided to go there because there's a lot of people there. So we went to the mall. Then while in the mall, we were like talking and like looking around, and we decided that hey, like let's get a ball, like a football, so we can like go to the park and kick it around, and Thor might be interested to like also play. So we walked around some shops. We couldn't find any place that would sell just a normal football. So we decided to go to another different mall, which is more like a construction type of, but also it has like food and also has uh like toys and whatnot. So we went there, we got the ball, then we went to the park, and then we went to play with the ball, and then we got home. So that entire ordeal was very walking intensive and a little bit tiring because like 3 hours or something. So went to bed a little bit later than I'm used to. So feeling a little bit jet lagged. But it was worth it. He got socialized to a lot of people, a lot of new places. So that's good. What's up with you? Went into a little bit of a story mode. Which technology allows us to write easy to read asynchronous code? Easy to read asynchronous code. All right, let's bite the bullet and actually like figure out what asynchronous means. Asynchronous programming is a way for a computer program to handle multiple tasks simultaneously rather than executing them one after another. It's obvious that Thor is tired. Well, he's always sleepy in the morning because my girlfriend wakes up at 5. I wake up at 6. And he's like just running around playing in the mornings typically. And when she leaves, he goes to sleep. So he's usually sleeping at this time anyway. But it was very obvious yesterday when he just came back, when we came back from the walk, he just walked into the room, drank a little bit of water, just plopped on the floor and fell to sleep. Not much for me getting ready for my exams. Are they today? Ah. Oh, wait, Saturday? Have exams on Saturday? That's a bit of an odd day for exams. Oh my god, come on. Paul, focus. What the hell, Saturday? Who even goes to school on Saturday? It's weird. Technology allows us to write assertions against HTML DOM content. JS DOM. Do you feel ready for your exams? Mm. Assertions against Node.js server response. Yes. Asserting that the string decade is contained within string Codecademy. Yes. Getting ready. Okay. Well, I guess you can't ever be like 100% ready because you don't really know what the exam is gonna entail. I don't know. Exams are just stress inducing to the max, at least for me. Like that's the whole thing. My whole gripe with like higher education and even like not even higher education but education in general is that you get tested you get tested basically on memory, not on whether you know how to use something and blah blah blah. And memorizing shit is dreadful for me. I don't like memorizing stuff. Back in school, in my literature class, we had periodically the teacher would give us an assignment to memorize a poem, essentially. So other kids they would memorize their poems and just recite them in class. The way I would do it, I tried memorizing it, but it was just so like boring and also very hard for me. So one day I was like I kind of wrote these little doodles of different words in the poem. So if essentially if a poem is like a dog is running through the street, right? I would draw a dog and draw him running through the street. And so I would have a sheet of these doodles. And one day I took one of these sheets to class and I asked the teacher, hey, can I use this as sort of a reference thing? And she was like, yeah, sure. So then it was easy. I just stood there with the sheet, basically just reading off the poem because I wrote it. That's how I memorized it. It was super helpful. Which technology allows us to write easy to read asynchronous code? I don't get it. It's 2024. Why should I memorize these things when I can look? Yeah, exactly. Like you have a computer in your pocket basically 24/7. Why is there still need for memorization? Okay, one sec. Gotta deal with some hooligans in chat. Yeah, I don't know. It's just bots. Like this long lived chaos comes in every couple of days. Just posts that one message and then leaves. Like he follows too and then unfollows after a couple of minutes. Just weird. What's the point? Well, unless he changes his nickname and creates a different user. I've seen async wait a lot. What is that? Is that a JS thing? Good question. I don't really know. They didn't really do much of an introduction. Essentially, what I'm what I'm thinking it is when you're testing, you are making requests to the server, which can slow down the server. So the async await technology or library is allowing you to make multiple requests at the same time, which shouldn't slow down the server, I think. But I don't really get it. Why is the test failing? Because it's not in the correct element. Which technology extends the assertion library of Node.js and provides assertion methods like include and not include? Chai. Like multi-threading stuff. Maybe. Not sure. I think we're gonna dive deeper into it, so maybe it'll become clearer as we go through. All right. In general, it is up to the developer to make a judgment call on how in depth to write a test. Every test written adds time to the testing cycle and can require maintenance if changes are made to the server behavior. For example, uh, extensively testing failure cases at the feature level might be more than is needed if the error behavior can be fully tested and described at the server level. All right, so as you develop an application, you may realize that you can replace feature tests or reduce them with equal coverage at a lower level. One question to ask when deciding what between a full feature test versus a server test is it worth trading a slow feature test for a faster server test that doesn't test the UI? Based on the context of the different levels of testing, you should aim to pick the set of tests that gives you the best combination of reliable, complete, and fast tests. In this lesson, you will use the server level testing technologies to test drive the development of an Express server. Server tests often provide feedback in terms of HTTP domain concepts like status codes, headers, keys, and values, and the content of the response body. Let's take a look at the feature level test and compare it to the corresponding server test in messages test.js to the right. All right, Irfan, good luck with your exam prep. See you around. Thanks for stopping by. So this uh, is a feature level test. Set value input author ID equals author text area ID message saves the message with the author information. Assert include message includes message and message text includes author. And this uses the asyncs and everything else that we've seen. Message form, author message. Okay, so when such a test fails due to a non-existent server implementation, the developer needs to dive into the server level and begin the TTD process to drive the server solution. Okay, so in the panel to the right, there is a corresponding server test to illustrate the differences between feature and server level tests. Compare the describe block to the feature test above. What's the difference of the feature test above? So posting a message when the message is valid. Okay. What's the difference? Well, this just checks if the message will post. This checks if the message is valid and then creates the message, I guess. I don't know. Status code. Server tests are slightly faster than browser-driven feature tests. Since the web browser is cut out of the test, we are not testing how things are rendered for the user. Instead, we're focused on the server response. One use of TDD at a server level is to measure that the HTTP status codes are returned as expected. Verifying status codes provides the most basic level of confidence that the server is functioning correctly. Having a test suite that includes status codes provides a quick check when implementing a new feature that we haven't actually accidentally caused a request for valid routes to respond not authorized or not found. Okay, so to verify status codes, we are asserting that the response status is equal to the status code integer that our application requires. All right, so assert equal response.status in this. Okay, if we use the red-green refactor approach to implement our server behavior, we would start out with an assertion like this and expect it to fail red. We then implement the behavior to pass the test and continue to refactor if needed, ensuring the test remains passing. Okay, so in the right, we started a server test for verifying the homepage returns a 200 status code. Add an assertion to check that the status code is indeed 200 and run the test. Okay, so assert equal response dot status is 200. npm test failed. Ensure that the done callback is being called in this test. This test failed, but that's good news. That means we've entered the red portion of the red-green refactor approach. Use res send within the server implementation for this route in the index.js. It should return an empty string when a request is made to the home route. What? Res send. Fudge. Take a look at that full implementation here. Send. Boom, 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 boom. Assert equal. Assert include. What in the hell is res send? What am I sending? Just do send res dot send empty string. No. What? You didn't add anything. To the server response. Try to return an empty string when a request is made to the home route. I don't understand. in the response for the slash. Um, what what did you do? Like, there, what, I don't understand. There's nothing here. You added nothing. Reset. Assert equal. Response dot status 200. npm test. Okay, it doesn't work. So now these are identical. Const response equals await request app get assert equal response status 200. These are identical, but now it doesn't work. We click replace with solution, and this is the solution, which is identical to my code. Oh, wait, you're supposed to do it here. Ah. Okay, I can't read. In index.js. Router get res. So res.send this. Test. Now it passes. I have no idea what I'm doing. I'm just following the tutorial. In the previous exercise, we checked that the server responded with a specific status with specific status codes. Now we need to make sure the server is responding with the correct content. Specifically, we are looking at HTML responses that are rendered by the front end. Many servers return dynamic HTML content based on the user, the URL accessed, header values, and more. We use TDD to ensure that the server responds correctly for each case. When designing our tests, it is important to consider both the intended and unintended user behavior. We can organize our tests into two categories. Tests that exercise the happy path, expected use cases of our application, and tests that exercise the sad path, unexpected or invalid use of our application. For our tests, once we retrieve the response from the server, we use assert include from the child library to check the response. As an example, after requesting a valid profile page for my name, you may receive the following response content. Okay. You can retrieve the content of my name and check it using the following. Response text. My name, my name. Okay. We could also write a separate test to check the corresponding SAT path. Perhaps there's not yet a page for your name, so you should not receive a response containing similar HTML. We use not include to verify that the response is not including your name. Okay. Not include. Note that we're identifying the HTML elements by their ID using our parse text from HTML. Helper, but you can use any selectors supported by the JSDOM library. This helper is returning the text content of the corresponding HTML element only, but you could write a separate helper for accessing other attributes. All right. We want our home page @ to contain an H1 element with an ID of page title. It should say messaging app. Add an assertion with the correct title. Test using the parse from HTML helper to check the response. Okay, contains the correct title, get. So we do assert include parse from HTML parse text from HTML. So we do response dot text hashtag page title. What's the correct title though? Oh, messaging app. The hell? Messaging app. What's up with you? Private identifiers are not allowed outside class bodies. Oh, this should be clauses. Oh, 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 oh. Okay, npm test. No element with a selector page title found in HTML string. Did you pass response text and home page title as arguments to parse text? I did. Oh. I wrote includes. It should be equal. But we're still failing. Within index.js, implement the correct response using resend and the intended content to change this test from red to green. Implement the correct response using resend. Okay, so instead of that we do this. Yeah. All right. All right. Let's take a break. I'm gonna hit the bathroom, and I will see you in 10. And we're back at it, back. Okay, let's get back into it. So, uh, in the previous exercises, we checked that the server responded with a specific message. On our homepage, the title is constant for everyone. Messaging app. What if we want to create a profile page that is customized for each user? A straightforward implementation would be to generate hard-coded routes for every single user of our app. Think welcome Alice, your name is Alice. Welcome Bob, your name is Bob. Okay, hopefully if you see repetitive code like this, you'll have an urge to refactor it to something more elegant using a variable route parameter. This allows us to put any username into the URL and have the server generate the appropriate response. Think welcome username, blah, blah, your username is blah, blah, params username. Okay. If you're using red-green refactor approach, you will start with a set of passing green assertions for the following, for the section of code you're looking to improve. The current behavior captured, you can begin refactoring, knowing that your tests will catch you by turning red if you miss something in your approach. Okay, so in Profile.js to the right, we have an implementation to provide customized profile messages for each of our users. Through TDD, we also have a set of assertions in profile test to verify we are providing the correct messages to each user. User. npm test. All right. Greets Bob and greets Alice. Sure. In profile, replace the string Alice in the first profile route with /username to make the username available as a variable. So we do /username. Okay, now we're failing. Expected welcome Alice to equal welcome Bob. Okay. Our test is now failing. Edit the welcome message in the route to the username variable. Instead of the hard-coded Alice. Edit the welcome message in the route. So this. Did you replace Alice in the response string with O plus this? And all of this should be in wait, I feel like I'm doing it in the wrong place. Yeah, likely. Should be here. Okay. So let's reset. Wait, no. Delete all of this. Return Alice. And in here, we do okay. Wait a sec. Welcome. Plus this plus. Okay, remove the second profile route for Bob. Now that we have a variable route doing the work for us. So this, do the same. Okay. We're failing the tests though. But at this point, you may decide to delete one of the tests, since the implementation is now dependent on the name as a variable only. The decision depends on the balance between the time your tests take and the cost of missing a potential corner case. Oh, we have to just get rid of it entirely. Tests still fail though. I don't know. Sometimes during the reflection of the refactor phase, you will realize that you can implement something better or more efficiently. In the code so far, we have been responding with the inline HTML strings. On a large project, this could make it difficult for the front-end developer to organize and maintain. An improved approach to this is using the templating library like handlebars to separate the HTML view from the JavaScript controller. In the web app that you've built in this lesson, you place the templates in the /views folder and have an extension of handlebars. Our controller will now use render to create the view and pass in any variables. Render template name param. Consider the previous profile page route implementation and profile blah 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 to the right. Check the existing code using npm tests. Sure. We've added a blank view called profile handlebars in the views folder. Copy this HTML response into that file. Okay. update the response in profile.js to use the newly created view and pass in the username, with the name of the view as the first argument and the username as the second variable username. Okay, so instead of rs_send, we use res_render, and then we do profile and the second argument username, like so. Looks like our test caught a small error in our new implementation. Can you fix it? So, welcome Alice. Welcome Alice. Oh, we need a exclamation mark here. Yeah. Okay. Next. API errors. As mentioned earlier, one of the use cases for server testing is for checking API responses, especially the SAT path, where a user interacts with the server in an unexpected or disallowed manner. We need to make sure that our server properly handles invalid passwords from field errors, form field errors, etc. Ensuring the app is designed to withstand these issues and that the error interactions are well bounded, it's important. Keep in mind that while there may only be one happy path for the interaction, user submits a valid password, there can be many corresponding sad paths. Password's too short, doesn't contain special characters, etc. By testing the majority of these on the server level, it saves us from testing them at a more resource-intensive level, including the user view. All right, so we added a new route to our application. It allows users to post a message. After this, the user should be redirected to root. There's a passing assertion that handles this happy path. We need to check the sad path where a user provides insufficient inputs. We have started a test in messages test to check the server response with an error message when a submission does not contain an author. Add an assertion to verify the server response to this case with a status code of 400. So assert. I have no idea what to do here. Assert equal. Check that the response status is equal to 400. Okay, so response status 400. Okay, so we failed. The test is failing since we have not implemented this behavior yet. Within messages.js, uncomment the code block that responds with the 400 response. Oh. Author equals unidentified. Response status 400. Set header content type application JSON. 25 message. Okay. Hey, we passed. Let's make sure the server responds with an appropriate error message as well. add an assertion to our test to verify the server is responding with a message of every message requires an author. Note that this API is returning JSON, so you will access the message content using JSON parse response text message. So assert equal JSON parse response text dot message. Every message requires an author. I think that's how you do it. Maybe. Who knows? But we should be failing now. Yes. The test is in the red. Add the correct string to the response in message.js. So here. Correct? Yeah. Okay. I'm doing things, but I don't know what I'm doing. Hey, Happy. How's it going? How's your morning? Or evening? All right, so in this course, we moved from the feature level to the server level for our TDD approach. When working with persistent data, you will need to continue down the stack to the model layer. We've updated the test from the initial exercise to the right. Again, we're checking that valid message is saved. However, instead of checking the return page contains a new message, we're checking the message is saved to the database layer. Sure. Message is not defined. The test fails since we have not yet implemented the model layer, which is in our next step as developer. My server crashed at work and I have no idea why. So my morning sucks. What about mine? So. I'd give it a 5 out of 10. I'm feeling a bit tired. Since yesterday we took a big trip with Thor outside. We visited the local mall, which has started allowing dogs inside. So since we're trying to socialize them to people, that was as good a place as any to visit, since it has a lot of people. But we came back home a little bit late, so now I'm kind of tired because I didn't go to bed in time. Server crashed. My server crashed. You have your own server, specific labeled Happy's server. You are following the red-green refactor methodology. What is the first step in adding a feature to your code? You write a failing test that describes the required feature. Yeah. It's a virtual machine and runs a few customer projects. I see. So I guess today is going to be all about uncrashing the server or figuring out why it crashed. How do server level tests compare to feature level tests? Generally faster and verify user interaction. Slower, server level tests. Well, they do verify. Oh, they do not verify user interaction. My bad. Get send. Server returns the correct content for the get route. Get of the base route. Assessing the server returns 200 HTTP status code for a get. Yes. And I'm alright for a long, long time. What parts of the application do our server test covers? API response, status codes, HTML response. Yeah. Or wait, Happy, is the server still down? Is that the problem? And you have to revive it. Manager asks you to update code in the server to use HTML templating library like handlebars. What is the first step you should take to implement this? Add a handlebar template in the views directory. Ensure you have tests that cover existing implementation. Add the handlebars library to the main JavaScript file. Well, RIT just told me that they've changed certificates. That's why I couldn't access. I love when they do things without telling me. Oh yeah, that's always fun. When other people mess around with your stuff without telling you. That was a constant problem in my previous workplace too. Because we had 4 shifts basically. And all 4 shifts were interacting with the same like machinery, right? So, but the problem is that each team is responsible for a different part of the machinery. So, on your shift, you come in, you like fix things up, you implement something into the production process or something, and then you leave instructions in how to work with that process. And then you come back after your 4 days off, and other shifts have wrecked things beyond comprehension. And now you have to just salvage whatever you can. That's always fun. It encourages teamwork. Boom, 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 boom. Ah, I don't know. The server stuff is not sticking in my brain for some reason. I'm gonna have to learn it better one of these days. Do 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 do. Ugh. How can this test be improved? Um, the test should be separated in 2 tests, one checking for an OK response and one checking for a not found response. Happy path and sad path should be tested separately. So if it fails, you can more efficiently pinpoint what went wrong. Sure. Your manager asks you to update code, blah, 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 blah. What is your first step? Ensure you have passing tests that cover the existing implementation. Yeah. You're following the red-green methodology. What is the first step in adding a feature to your code? Write a failing test. How do server level tests compare to feature level tests? And do non-verify user interaction. What is the following code testing? Do, 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 do. Which statement best describes the type of testing for server response content? Which statement best describes the type of testing for server response content? Test only a happy path of server interactions. The sad path tests are best saved for other testing levels. Happy, are you familiar with the sad and happy paths? Saved for other testing level. Test both happy and sad paths. Yeah. Please tell me we're done with server stuff. Oh no. A project. Okay, but we're almost done. You will write the server tests for a web application that allows users to save and display a collection of their favorite quotes. We'll call this app Quote Keeper. The app currently has a feature level test which submits a quote source and who it is attributed to. It then asserts that that it is displayed to the user. Since the existing tests were solely at a feature level, it was unable to pass. We're diving into the server level. Steps below guide you through TDD approach to implement the corresponding server behavior. Okay, this doesn't seem too bad. The scope of our test is that the user should be able to submit a quote and have it displayed back to the user upon submission. The feature version of this test is located at userVisitRouteTests.js. Okay. We have index tests. Run this test and observe the results. npm test. 0 passing, blah, blah, blah. Element could not be located on the page using given search parameters. Right. Let's add a server level test in test routes index.js test. Here. Set up a describe block for slash with a nested describe block for post. Oh, crap. We need examples. Bum, 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 bum. So, unselected, return. Oh, this is parse from HTML. Okay. Describe. Describe. Send message. Okay. For the setup, declare and assign strings to variables for quote, attributed, and source. Declare and assign strings to variables for quote, attributed, and source. All right. Quote. Fix that damn server. Attributed to develop with app be. Wait, now I'm curious. Develop. Do you stream as well? You do. Holy crap. How did I not realize that before? But you'd probably stream in German, I assume. Or maybe you don't stream. I don't see any VODs. Well, gonna give you a follow. Do, do, do. Um, what was I doing? No, not here. I was doing something here. This and const source equals Twitch chat. Okay, so that's fine. For the exercise, make a post request to root submitting these variables. Make sure to include type form to submit the dataset as a form. How? Okay. Request app. Dot post slash dot type form and dot send quote attributed and source. All right, sure. For our assertions, let's check the status code is 200 and that the response contains text or a quote. We are expecting that this text to be located in a quotes element. So we're still failing, right? Yes, we don't have unexpected token. Could be here. Yeah, could not be located on the page. Just gonna copy paste this, honestly. The status code assertion is passing, but the rest of the server level test is failing, just like the corresponding feature level test. When the quote is submitted via HTTP post, the response does not include the submitted quote. We've added handlebars to the project to allow you to respond dynamically. You can use the current response. You can see the current response is empty. Copy the current code from index.html into handlebars. Sure. The test failure message should be different now. Is it? It is. All right. Since we don't have a database set up yet, for now let's respond with this submitted quote to the user. The data won't be persistent, but it will demonstrate the proper behavior. This would be refactored when we move to the model layer. Code for the handling of the data post is around index.js. Within the handling for a post to slash, capture the submitted data by destructuring Rick body. Huh? I have no idea what's going on. I'm just copy pasting shit at this point. Bots QZ1. Hello. How's it going? We're doing some server stuff, but everything's just going over my head at this point. I have no idea what I'm doing. This dude. I appreciate your confidence. How are you doing, man? What are you up to? No element with selector quotes found in the HTML string. Okay, let's just say we did this. Now we need to render the template with this data. Again, in routes index.js, pass these values to the render method. Okay, so res render, and we just do source attributed end quote. Like your title, I remember when I started, the novelty in learning the basics is so special. It is when you understand it. I don't know, something to hide for such a R word. I don't know what that means. It is when you actually understand what you're doing. But I don't know what it is with server stuff that just doesn't, like, I do not understand server stuff at all. I'm fine with all the back-end stuff, blah, 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 blah. But when it comes to server interaction with the server, like the server interaction with the client, it's like I just lose all comprehension of what's going on. Do I understand stack heap? Maybe. Also, check him. Hello. High on oxygen. Well, I guess if I'm saying maybe, then I don't understand it. They're both really important concepts you will never forget. What are stack and heap? I know what a stack is. I may know what a heap is. Oh, no, I know what a stack is in terms of data structures. I don't know what a stack is in terms of server stuff. Oh, wait, no, it's the same thing. Never mind. Are we expressing son? We are server testing son. Heap is addresses to memory you can change dynamically. Client is like a stack. Okay. I mean, sure, that's good to know, but the thing is, I don't even understand like the basic stuff that's happening here, like post, renders, freaking handlebars, blah, 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 blah. It's fine. Watts, it's fine. I'm just gonna breeze through this. This is not really the primary focus of my learning journey, to be honest. I don't entirely need this at all. I'm just doing it for test to just get a basic grasp of JavaScript testing. I'm fine with forgetting all of this and only learning it again if I ever need it, which I probably won't. Okay, check him. How are you? Haven't seen you in a while. Was it last Friday, I think? When we were playing Balatro? You hopped in. How you been, man? How was your weekend? Use handlebars to render the quote within the quote section at the top. This can be done how you like. Our test is just checking that text exists. So we just toss this into the handlebars. Edge. Stuck in WoW since 3 days. Let's say I haven't coded any. Dude. We talked about this. Don't do it, man. What if I just toss it here? Sure. So our test should be passing now. NPM test. No. 32 hours in 3 days. No, it's not fine. Check him. It's not fine. What the hell? Route index. Post. Wait. Render the quote within the quotes section at the top. Okay, so we need to render this somehow. With this, I guess? Just do another res render. Um, what the hell? No. Okay, I have no idea what I'm doing. I never used render with Express. That's weird. I've never used render. Everything is weird for me. Wait, what are we doing? Use handlebars to render the quote within the quotes section at the top. Where's the quotes section at the top? What are you talking about? Uh, or do we just post this here into this? Like here? Maybe? No. Huh. So what do you do in life? Studying, working. How are your days going? We got a lot of students here. Ah, fuck. Mm. Just hit my elbow. Ah, this hurts. Oh, wait. We do have the quote section here. Right, we just passed this here. Yes. And now you're still failing the test. It says our test is now passing. Express, blah, 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 blah. Hmm. So add an empty handler for a get within routes index.js. Router get. Just here. I think I failed somewhere in the beginning. Okay, you know what? I don't have the patience for this today. Fuck that. Code coverage. We're just gonna skip through it because I don't see myself using the server stuff. If I ever need them, I will learn them. This, for me to fully understand what is going on in the thing before, I would have to just finish an entirely separate tutorial related to server stuff, and not today. So in this article, you will learn about code coverage and test coverage, two metrics that organizations can use to determine the extent in which application code has been tested, and why these metrics are useful. Amount of application code that has been executed in testing, represented as a percentage. For example, if 90% of our code has been executed in our tests, then we would say that we have 90% code coverage. But what does it mean for code to be executed in a test? How rigorous does a test need to be in order to qualify as having executed the entirety of a program? And does 100% test coverage mean that a program is bug-free? Measuring code coverage is conducted using one or more criteria depending on the organization's standards for code coverage. Though this is not an exhaustive list, some key criteria to use when measuring code coverage include function coverage, statement coverage, path coverage, and condition coverage. I hate touching code over years ago. Doesn't it give you like a perspective where you see that you've improved? No? Maybe that's not a thing after a couple of years of coding, or like when you have enough experience. Um, I'm looking at it since an hour, and I know what it does at the end, but I really don't understand what I did. I'm sure you can figure it out. By the way, Happy, I checked your stream. Do you stream at all? I followed. something in your nickname clicked with me, and I was like, develop with happy. That sounds like a streamer nickname. I was like, you got a stream. So I checked your profile, and you do have a sort of semi-stream setup sometimes, but not that often. Do you not? Oh, okay. So if even if you have VODs, they're probably gonna get deleted after a week. Well, I followed you either way, so I'll stop by if you're ever streaming. Hmm. No problem. I don't know. I do enjoy visiting like smaller streams for some reason, as opposed to like the big streamers that have like hundreds of viewers or thousands of viewers. Just seems like chaotic place to be at. Can't really talk to the streamer. You're just watching them do stuff while the chat is flying by at subsonic speeds. Okay, the most basic test of this function would include calling the function at least once, thus achieving 100% function coverage. By executing the function only once, and with the argument above, we will execute some but not all of the lines of code in the function. So we can test our function by calling it with arguments that will return null. Okay, with these two calls together, both paths in the if-else blocks are taken and both return statements are executed. Thus, we have 100% statement coverage and 100% path coverage. Finally, to achieve 100% condition coverage, we need to call our function with arguments such that x and y each evaluate to true and false in the function's if condition statement. Okay. The 100% code coverage myth. And there we have it. We've reached 100%. We've achieved 100% coverage in each of the 4 criteria. So we're done testing, right? Well, not quite. Having 100% coverage does not guarantee bug-free code. It simply validates the completeness of our tests using a given set of criteria relative to other test suites with lower code coverage. We still must be vigilant about writing robust test suites that specifically address both the intended use case and the unintended edge cases of our application. So, for example, as written, the numsum function will concatenate numeric string arguments rather than performing addition. All right. While there are other coverage criteria we can use to identify the full range of function parameters, code coverage is an insufficient metric to determine if our tests confirm the intended functionality of our program as defined by the end user's requirements. Instead, we should consider the code coverage criteria as a set for guidelines to help you develop intuition for testing your code while remaining determined to write robust test suites that are specific to in targeting the various use cases of our program. Sure. Another term you may hear with regards to testing is called test coverage. Test coverage differs from code coverage in that test coverage measures the percentage of the required feature specs that are tested as opposed to percentage of lines executed. These feature specs are typically defined in a requirements document provided by a client or product designer. Made a small express tutorial if you ever need it. Yes, please. I need everything. Gib. People are sending me crazy stuff. Like, I got like lecture notes from Irfan, I think, on databases because he's like learning databases in university and he has an exam soon. So he sent me like his lecture notes. Now I'm getting tutorials from Checkham. This is amazing. Suppose you're building a mobile native application that needs to work on phone using Android and iOS operating systems, but is not expected to work on desktop browsers. Accordingly, to achieve high test coverage, you will be expected to write tests for your application's performance on Android and iOS, but not on browsers. Like code coverage, test coverage cannot guarantee that our program will not have unexpected behavior. However, the pursuit of high test coverage can lead to lead us to identify bugs and unexpected behavior earlier on in development process. It's on my Discord though. I have everything I ever did on it. Okay, toss me your Discord. I will, I don't know, add you or something. Or you could hop into my Discord and join my Discord so then I can go to your Discord. Oh, wait, does that work like that? I don't know anything about Discord. I just made it so I was like, so I could post some updates about streams and whatnot. All right, are we done with testing? Almost. We have mocking and spies. All right, so what is mocking? Omega. Oh, okay. One sec. Let's see. Omega 13. Or Omega hashtag. Uh, the O is a 0. Oh, I see. Because I'm cool. 2213. No results. Discord is giving me an empathy banana. Okay, how about you add me? Oh wait, crap. Maybe I'm doing something incorrectly. Mocking is the process of creating fake versions, creating a fake version of an external service for sent. Okay, take a look. I got something pending. Accept. There we go. If you want to join my Discord server, you can find it in the About section. Mocking is so creating a fake version of an external service for testing purposes, particularly in unit tests and integration tests. Mocking is effective in testing individual units of code without relying on the functionality of other services or units such as APIs or databases. Another word that is used to describe this practice is stubbing. While there is a difference, it's not a very relevant difference in this scope and context. Yeah, it's very cool. Wait. Omega. I hate code. I like the wolf. Very expressive. Let's say we're testing a feature for a blog website which renders profile data. Blah, 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 blah. Mocking in unit tests. As mentioned above, mocking allows us to test a particular feature without needing to rely on other services or units. By removing dependencies, we're limiting the resources. We're limiting the sources of potential bugs and unintended results to just the features being tested. Okay, that's small tutorial. Oh, wait. In the backend section in Express Base. Holy crap. So much stuff here. Front end, back end. Database, WordPress, mobile, OS. in the backend section. Backend Express. There. Ooh, it's a video tutorial too. Holy crap. Is it the last one? Express.js full course. Okay, do you mind if I show this on stream? I want to take a look. He's seeing away. Everything's up. Okay, let's take a look. 8 hours. Holy crap. What is it with people using this particular font? I've seen quite a few people use it. Okay, this will be incredibly useful if I ever need it. Thank you, man. I will definitely keep this in my back pocket. But I made my own tutorial because 8 hours every time, just have to use server and wait. That's why I made my own tutorial, because 8 hours every time just to have a server running is a nope. Ah. Yeah. Okay, that's very useful. Thank you. Yes? We're saying something? Door's making weird noises. Ah, crap. Mocking. Mocking allows us to test a particular feature without needing to rely on other servers, services, or units. By removing dependencies, we are limiting the resources of potential bugs and unintended results, blah, 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 blah. In our blog application, the new feature has 3 steps. Profile data must be fetched from the database. The data received must be parsed and formatted. The formatted data is rendered. When unit testing how the data is displayed, we can skip the first 2 steps. By mocking the formatted data we need, allowing us to focus solely on testing how our feature renders the data. We can even mock bad or unexpected inputs to test how the feature might display an error message. Okay, I get what it is at a basic level, I suppose. While it is helpful to use mocks in unit tests, we should avoid using mocks in integration tests to better simulate interactions between internal services. Okay. What is a mock? So, a fake version of a service used for testing purposes by the unit being tested. Which of the following is a benefit of using mocks? Possible limited amount of code being tested without depending on other services. Which of the following is true about using mocks with integration tests? We should avoid them. Integration tests should mock external services but not internal services. Integration tests should use mocks for every service. Oh. I don't know what is it with me today. I just cannot focus or internalize internalize stuff today. What are spies? Step aside James Bond. In this article, you'll learn about spies in the context of testing and about the Synon.js library. In testing, a spy function that observes and records information about another function. A spy is a function that observes and records information about another function's calls, including arguments, return values, the this value, and exceptions thrown, if any. The information that is observed by the spy can then be used in assertions for testing. As an example, let's say we are testing a top secret application with a feature to receive a message. Display for 5 seconds, then delete it. We can wrap a spy around this unit to keep track of how many messages were received, what messages said, if any errors were thrown, etc. Using its stealthy powers of espionage, the spy won't change anything about how the function operates. It will just observe what happens. Okay. Synon.js is a JavaScript library that includes standalone fakes, spies, and mocks that can be used in any unit testing framework. The Synon spies documentation highlights the different information that can be pulled from spies. So there are multiple ways to use a spy. They can be anonymous functions or they can wrap around existing methods in a program. You can see all the many ways to use spies in the documentation, but we'll focus on one type in particular, wrapping methods. Our spy will be wrapped around a method, and we use the method in our tests. We'll observe everything that happens involving that method. We can think of a spy with a wiretap, taking notes on every interaction that method has. Okay, so this is just a unit. In the example above, the synon.spy method is used to wrap the robot object's greet method. What? Where? Oh, here. Ah, so you do it like so. Spy on the robot object greet method. Okay. Doing so adds a number of useful properties and methods that allow us to monitor its behavior after we call robot greet Cody. Using a few of these methods, we test if greet method has been called using the called property is called with the correct argument, returns what we expect it to return using returned property. Finally, to ensure that the method returns to its original unspied on state, we use the restore. Greet restore. We remove the spy. What if we don't remove it? Huh. Okay, what is a spy in context of testing? A function that takes fake information. No. Function that asserts information. Devious hacker who intends to learn how to break source code. Fill in the blanks to properly set up a teardown spy. Synon spy. Object my function. What is it? Remove? Restore. All right. So we are done with JavaScript testing. The end was a little bit shaky there with the server stuff, but we did finish it. I just kind of rushed through it because I don't foresee myself using it anytime soon, especially the frameworks, because I'll be pivoting to an entirely different area. So the only thing that I wanted to do was just see unit testing instead of server testing. But we're done with this. Okay, so um, as per our roadmap, we are gonna jump today back. Gonna jump into hey Tiberian. Shaking is a main force of learning. Sitting and shaking equals profit. uh, yeah, but we don't really need it that much at the moment. So I just kind of glanced over the server stuff, and we're gonna jump into DevOps fundamentals and probably GitHub as well, depending on the size of the chapter. Let's take a look. Actually, DevOps fundamentals. Oh, it shouldn't be too long. We should be able to check out the fundamentals. And where's the GitHub stuff? Uh, GitHub stuff is also not too extensive. So hopefully we can finish both of these today. And then tomorrow, then we're going to jump into the advanced stuff of SQL, probably. How's it going, Tiborian? What are you up to? How's your morning? Okay, 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 okay. Ah, really well. Trying to get the first cup of coffee. I already had 2 cups of coffee, believe it or not. It has helped immensely because I woke up sort of drowsy and just like as if there was a blanket on my brain, but it has helped. Not in terms of yawning, though. Still yawning, but thinking more clearly. Let's see. We have 11:14. Hmm. Okay, let's push on. Let's skip the small break, and then we'll do a lunch break in roughly 45 minutes. Okay, so what are your plans for today? Work, probably. Uh, in this unit, you will learn some of the fundamental concepts of DevOps. DevOps is a culture supported by practice and tools, and it is transforming the way development and operations teams work together in an organization all over the world. After this unit, you will be able to understand what DevOps is and what it aims to do, identify the central pillars of a DevOps culture, and describe the DevOps practices that support DevOps culture, and discuss the basic of infrastructure management. Introduction. So, Ariadne needs a new database server to support her new search feature. This should only take a few minutes, but it's stuck in the operations team's backlog. She might have to wait months for this simple task. What's going on? A lot of work as usual. Also found out yesterday breaking pull request from my coworker and needs to fix it. Everything's breaking for everybody today. Happy came in with her server broken. Now she's working on trying to get it back up, or I don't even know. Either working on trying to get it back up, or trying to figure out why it crashed, I suppose. Stuff's breaking for you as well. Checkham's insanity is gonna break because he's playing too much WoW. My brain is also breaking from lack of sleep. Ah. um, Ariadne's company could use DevOps. DevOps is a culture supported by practice and tools. This culture enables development and operations teams to work together. The resulting collaboration aims to achieve faster and higher quality productions. In this article, we will provide an introduction to DevOps, its benefits, and key concepts. Throughout the article, we will provide links to other articles you will encounter in this unit. Okay, but my priest is autonomous in mana regeneration now. Can DevOps do that? I don't. Autonomous in mana regeneration. What does that even mean? That it is automatically regenerating mana? Traditional software company often has a development and operations team. I regen more than I consume. Okay. Okay. Wait. What is the wait, let me see. Where's that emote? Yeah, there we go. Wow. Impressive. Check. Actually, when I think back to my WoW days, that would be impressive, but a little bit less these days. Ah. Wait, what day is it? Is it? Oh, it's only Wednesday. Holy crap! It's too early in the week for me to be slacking off like this. The development team writes an application's feature. The operation team creates and maintains the infrastructure that the application runs on. The development team sends its code to the operations team, who deploys it on the infrastructure. Okay. Developers sending new features to the operation team creates a conflict. Developers want to produce new functionality as fast as possible. Operations members want the infrastructure to be stable and reliable. New changes are biggest threat to the stability of a system. This difference in goals puts development and operations at odds with each other. Conflict and separation between the development and operations teams interfere with production. When an operation team is separate from development team, differences between environments can lead to difficult bugs. Handoffs between teams take time and can risk the loss of information. DevOps aims to end the divide between the teams, changing the production dynamic. Does it actually succeed in doing so? I don't know. We should ask Tiberian and Happy. Do you guys have DevOps in your companies? DevOps seeks to integrate development and operations by having them work together. By integrating development and operations teams, we can have consistent development, testing, and production environments, fewer handoffs, and shared information and context, management of infrastructure with development tools. DevOps help me. So, Tiberian, do you feel like you have consistent development, testing, and production environments? Also, fewer handoffs and shared information and context, and also management of infrastructure with development tools? Or is it one of those just fancy, I have it even on a small side project? Okay. Is there any benefit to it? Because we had a similar thing, or like a similar system set up in my previous workplace. It wasn't like um it was on a bigger scale, I feel like, because like DevOps aims to sort of combine the workflows of development and operations, whereas in our system try to not combine, but sort of integrate bits of everything into of the entire factory. So isn't TypeScript fixing like half testings? I don't know what that question means, Checkham. A lot of benefits. You can test everything without breaking things in a production, and you should not trust to developers. Oh, I see. Okay, well, at least there's some good. Because the system we had set up in my previous workplace was horrible. Like some of the things were okay, but also do not trust yourself. Well, yeah. Everyone makes mistakes. Okay, so the culture of DevOps is the most critical factor to its success. Collaboration cannot occur only from applying a set of practices and tools. It requires a culture in which collaboration can thrive. The central pillars of a DevOps culture include thinking about the whole production system rather than a single department or part, feedback loops allowing each part of the process to receive information and improve, a culture of continuous experimentation and learning. DevOps culture is about to make things work and useful for everyone in the team, which is not possible but needs to try. Yeah, I mean, I feel like these like schemes or systems and whatnot, they rely a lot on the people, and people are never gonna be like there's never gonna be a scenario where 100% of the people in the company are on board with something. And so when your system relies on people being on board of the system for it to work, then it's just not gonna work. At least not to its full extent. Mm. While these are while these ideas are useful concept, there needs to be a practical means of applying them. DevOps has a variety of practices that support this culture. All right, so automation, making manual processes occur automatically instead, continuous integration, regular merging of contributor code into a central repository, continuous deployment and delivery, automatically preparing code changes for release, infrastructure as code, microservice, dividing up a business application into many small independent services, monitoring, gathering information about the state of the system during runtime. All right. So tools. We can organize DevOps tools into some general categories. Many options exist for each type. Source control management, which are tools that help developers track and manage source code changes. Git is the most popular source control management tool. Okay. Environment tools. Environment tools assist with the configuration of hardware and software for running code. Popular environment tools such as Docker and Kubernetes. Okay, I see. Automation tools assist in performing routine tasks via scripts. Popular automation tools include GitHub Actions and Jenkins. Infrastructure as code. Tools allow us to define infrastructure as source files. IAC allows us to manage and track changes to our infrastructure over time. Popular tools include Docker, Chief, and Terraform, and testing. Leroy Jenkins, it's a sign. Where's trying to remember now. Burning Lands? No, not. Is it in Burning Lands? I haven't played WoW for so long I even forgot the map names. Burning something. I know there's a volcano where that raid is in. You go into the volcano, then there's a raid, and it's full of dragons. And the last boss is a big dragon, I think. Blackrock thingy. Yeah. It's full of dwarves and stuff. Okay, this is interesting. What is interesting to me is the fact that in a lot of job ads, you see people asking for, you see companies asking for knowledge on things like GitHub, Docker, Kubernetes. Um, I've seen Chief and Terraform as well, but I've never seen anyone ask for Jenkins, for example, or Mocha. I don't know if that says anything. Look in my doc and tools section. Okay. Crap. Doc and tools. Java, Rust, Vocal, OS Mobile, backend, front end, doc and tool. Okay, we have Docker here. That's good. It's not even exhaustive, and I haven't dig into half of it. Oh, there's quite a lot here. Holy crap, this is like very useful. Docker in 1 hour. Okay. Introduction to the culture of DevOps. The team was in the middle of production launch party when the alarms started to ring. Customers are not able to place their orders. The group holds a meeting. Who caused this? A manager asks. The room is silent. It must be something with the code, an operation member says. Our code is fine. The problem's in the infrastructure, a developer replies. The blame shifts back and forth for hours with no resolution. How can problems get solved when no one can agree on anything? It's Checkham. It's Checkham's fault. He wasn't coding. He was playing World of Warcraft, and now we have bugs in our code. You happy, Checkham? DevOps seeks to change the dynamic between many operations and development teams. It aims to enable trust, collaboration, problem resolution, and continuous improvement. The tools and practices of DevOps will produce little benefits without such a culture. In this article, we will discuss concept DevOps team uses blah 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 to enable this culture. Systems level thinking, continuous learning, experimentation, feedback loops. Yeah, but I'm autonomous, so can good moves. Yeah, instead, when a customer is not able to place an order, you just send them a message. I'm autonomous. Get good, noob. Or get autonomous, noob. Systems level thinking. With a traditional team, we often focus on our tasks rather than the big picture. Developers might concentrate on the code without considering infrastructure or testing needs. The operations team might only consider infrastructure needs without considering impacts on functionality. DevOps seeks to have each member of the team consider the entire development process. All members share responsibility for the final result. Thinking about the whole process or systems level thinking requires the involvement of many perspectives. To achieve systems level thinking, the DevOps culture creates teams comprised of people from many domains. A team might have several developers, but also at least one operations member. The goal is to have a diversified skill set across the team. Development members will pick up aspects of operations, and operations members will gain knowledge of development work. These knowledge gains allow members to make better decisions at each development stage. Always depends on the project size. On a small project, sure, you can be autonomous. Well, yeah, makes sense because it's a small project. But then again, depends, right? if that small project is like later going to be part of a bigger project, then, or I don't know. These knowledge gains allows members to make better decisions at each development stage. A bottleneck is a system's lowest point, causing a slowdown in the entire process. When each team member is only looking at their small piece, the big picture is often made invisible. This makes identifying bottlenecks more challenging. A A development team with an expansive process view can resolve systematic issues and increase throughput for the entire process. Resolving bottlenecks is a process of gradual improvement and setbacks. Let's discuss how DevOps seeks to always keep improving. DevOps seeks to include process improvement as part of everyday work, combining development and operations teams should expose a variety of inefficiencies. The teams should identify ways to simplify, and automate their production processes. So much reading. Though we intend to make improvements, making changes will result in new problems. These problems are an expected part of DevOps. Failure is an opportunity to learn rather than something to punish. One method DevOps uses to normalize failure is through blameless retrospective, aka post-mortem. Teams hold retrospectives at the end of a sprint, project, or issue resolution. Here, team members discuss what went well and as well as things to improve. Members should base improvements on information coming from the systems. DevOps requires information to flow through the development process. Let's discuss the way DevOps creates these feedback loops. So, strategies to incorporate feedback into its processes is an ongoing basis. Let's take a look at a few of these feedback loops. Metrics. DevOps seeks to use metrics from each stage of the development process to improve and adapt. Operation members can help developers build monitoring into their applications, build processes, and deployments. This information will better inform developers on code quality and reveal defects. Larrigan, thank you for the follow. How's it going, man? Welcome to the stream. We're learning DevOps, at least for today. Monitoring, blah, 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 blah. Adding metrics to the software can be very helpful, but having too many can produce unwanted noise. We must focus on metrics that affect the customer. Some of these include time to load a website page, time to issue outage resolution, time to new feature release. Okay. Shifting left. A defect or problem becomes more expensive to fix as it moves along the development process. A defect with someone's idea is cheap to resolve. When that defect has made its way into thousands of servers, fixing it is much more expensive. DevOps seeks to discover defects as early as possible, a strategy known as shifting left. Okay. So fix stuff as early as possible. Building quality in. Involving even more teams can lead to further improvement. Teams like security and accessibility can integrate with development teams as well, considering aspects like these throughout the development process is what DevOps refers to as building quality in. Okay. Complete the following paragraph. What in the hell is this? Deb and Jane want to know more about how customers are interacting with the products they're creating. They decide to create a metric, I guess, for measuring the customer's satisfaction, the rate at which customers return to make a second purchase on the site. By using these measurements to guide the design of their offerings, Deb and Janet are creating a feedback loop. Match the DevOps practice to its definition. Gathering information about the state of the system during runtime. That's monitoring. Regular merging of contributor code into central repository. That will be infrastructure as code, representing aspects of infrastructure configurations as source file. Okay, this should be infrastructure as code. Regular merging of contributor code into a central repository. Automatically preparing code changes for release. That's automation. Dividing up a business application into many small independent services, microservices, making manual processes occur automatically. No, this is automation. Automatically preparing code changes for release. I guess let's try this. Regular merging of contributor code into central repository, delivery, and deployment. Yeah, the other way around. Reduce handoffs, make environments consistent, and apply development best practices to infrastructure. Okay, so this was here. This was here. Monitoring, microservice, automation, continuous integration. Yep. A type of tool assists with keeping track of and incorporating changes to code. Keeping track of and incorporating changes to code. This like source control management. This type of tool assists with the configuration of hardware and software for running code. That is the environment management. This type of tool assists in reducing manual work. Automation, I guess. And this type of tool assists in ensuring that an application performs as expected. Testing? Yeah. All right, which of the following describes the mindset of a DevOps team? This team seeks to create culture of secrecy, allowing them to gain competitive advantage over the organization. I like this one. Team members seek to be highly specialized in their role, performing only one aspect of production very efficiently. No, the team seeks to rely on outside teams as much as possible in order to focus on what they do best. Communicate and share responsibilities across all aspects of production. Yeah. So this is metric and feedback loop. When building a culture of continuous learning and experimentation, practices such as encourage seeing failure as something learn from rather than punish. Blameless retrospective. When analyzing their production process, Kathy and Steven discovered that most work items are stuck seeking department head approval. This is causing major delays. Receiving department head approval is an example of a bottleneck. By looking at the entire production process and not just code development, Kathy and Steven are practicing systems level thinking. Which of the following describes the intended relationship between development and operations teams within a DevOps culture? Development sending res- development sending source code to an operations team to deploy it on an infrastructure. Well, no, that's just normal stuff. Development and operations members working on the same team and sharing responsibilities. Yes. Development and operations keeping completely separate from each other. No. Operations members engaging or managing the development team. No. DevOps is a something of collaboration between development and operations that is supported by practices and tools that is supported by culture. What? Oh, it's the other way around. Gosh darn it. Oh well. So this is still on the DevOps thing, I think. Yes. All right. But I guess we'll finish this when I come back after a lunch break. Yeah, because I need to hit the bathroom. Thor needs to hit the bathroom as well. I need to eat something because I'm getting quite hungry. So yeah, we're taking a little bit of an earlier lunch break today. But I guess it doesn't matter because it's always the same amount of time. Um so yeah, 30 minutes like usual. I urge check him especially to take a break from WoW and go get something to eat or something. But other than that, I'll see you guys in there. All right. I'm back. Uh, had to extend the break a little bit. My food took longer to warm up than I was expecting. Wait, did I? Lergan. That's a new follow, I think. Did I thank you for the follow? I don't remember. Well, thank you for the follow. All right. We can jump back into it and take a look at what is infrastructure and traditional infrastructure. So, using a web application often feels like magic. We click a link and our browser becomes populated with a website. Yet, this data had to go through wires, servers, perhaps even oceans before making it to your screen. When something goes wrong on this journey, web pages become slow and unresponsive. The feeling of magic can turn into frustration. The outcome of user experience, magic or frustration, often comes down to infrastructure. In this article, we'll introduce traditional infrastructure, problems that arise, and the role of operations teams. So, infrastructure is hardware and software used to develop, test, and deploy applications. Examples of hardware components include computers, routers, switches, data centers, and cables. Software components include operating systems and web server applications. Infrastructure components seek to prevent disruptions to the web services that are costly to the business, reduce delays in the flow of data, which can affect user experience, and protect sensitive customer and business data from cyber attacks. In practice, these goals are challenging to achieve. Let's explore why. What is it, Thor? Thor? What is it? What are you listening to there, huh? Neighbors walking around? You don't like that? So, historically, businesses managed their infrastructure on company premises with their staff. Due to the complexity of infrastructure components and how they interact, this is this can be a tall order. Okay. Some of the problems that companies run into when managing their infrastructure include hardware components such as power supplies, hard drives, and RAM that fail over time. Malicious users attempt to disrupt web services and steal sensitive data. Software becomes outdated, requiring consistent patches and upgrades. Differences in development environments can lead to bugs and taking full advantage of the computing resources of each machine. Getting ahead of these problems comes with some costs: staff hours, equipment purchases, and power. Moving to a cloud based infrastructure mitigates many of these challenges. We'll explore this trend when we learn about different types of infrastructure. So, who makes these decisions and handles these issues? Well, that's the operation team. The operation team's primary responsibility is managing the business's application infrastructure. This role has a massive impact on user experience and the success of the business. There are dozens of tasks that fall under this responsibility, including installing and replacing physical components such as servers, switches, hard drives, performing software, firmware upgrades such as security patches, configuring infrastructure such as firewalls, user access, and ports, and also monitoring network health and alerting personnel when issues arise. A vast amount of responsibility falls onto the operations team. In the DevOps culture, development and operations members share some of these responsibilities. Okay. So, environments. What are environments? An environment, in the context of creating and deploying software, is the subset of infrastructure resources used to execute a program under specific constraints. Throughout the various stages of development, different environments are used to handle the requirements of the development and operations team members. Each environment allows developers to test their code under the environment's specific set of resources and constraints. Though the names and number of environments can vary from organization to organization, the five environments we will cover in this article are the local development environment, the integration environment, the testing quality assurance environment, staging environment, and the production environment. To give context to the environments explained in this article, we'll use an example of a company that is making an email client, such as Gmail. Okay, so a local development environment is where programmers initially build the features of an application, often on their own computers and with their own unique version of the project. In local development environment, a programmer can work on their feature without worrying about or potentially breaking what other developers may be working on. In this environment, the developer can run unit tests as well as integration tests with mocked external services, while end-to-end tests are less common. Usually on small projects, environments is dev, stage, UAT, and production. Dev, stage. What is UAT? Local development is in ignore. Is it? Oh, it's the name of staging environment. Okay. That's interesting. But don't you need like testing on a small project, even if it's a small project? Dev is for testing? Okay. That's interesting. Okay. So then we have integration. Wait. In our email client example, the local development environment is where developers would be programming all the features and functionalities of the client. Individual developers may each be assigned a locally develop to will be assigned to locally develop and test in isolation a single feature, such as fetching the user's emails, displaying them, navigating between emails, drafting emails, etc. Then we have integration environment. The integration environment is where developers attempt to merge their changes into a unified code base, often using source control software like Git. The application is likely to have tests fail during this integration step as multiple developers who had previously been working in isolation simultaneously attempt to merge their code. If this happens, developers can work on fixes in their local development environment and attempt to merge again. Integration tests may need to be updated in this environment as well. In our email client example, as developers complete their individual features locally, they may simultaneously attempt to integrate their changes into a unified code base. I see. So you basically develop a small feature, try to push, and see what happens, basically. QA testing. The quality assurance environment, or aka the testing environment, is where tests are executed to ensure the functionality and usability of each new feature as it is added to the project. These tests include unit tests of individual units of code, integration tests of interactions between internal services, and end-to-end tests, which include all internal and external services running. When these tests are written and performed, when these tests are written and performed depends on the organization, but new and existing features are typically run against a test environment throughout the development process. The test environment typically requires less infrastructure than is used in production. In our email client example, tests run automatically when there is a change to the main branch to verify the functionality of units in isolation, such as testing displaying an email with mocked data. They also have integration tests executed that exclusively test the application's internal services, the client as a whole, with mocks for any external services needed. Okay. End-to-end tests would also be conducted that use real networking and external services with the client working as an actual email client. The staging environment is an environment that attempts to match production as closely as possible in terms of resources used, including computational load, hardware, and architecture. This means that when an application is in staging, it should be able to handle the amount of work it is expected to be doing in production. In some cases, an organization may choose to employ a period when the project is used internally, often referred to as dog fooding. Dog fooding. Tiberian, do you have you encountered dog fooding at any point before moving to production? In our email client example, the email client will be fully functional at this stage and will be tested, simulated, and in use internally within the organization. The architecture and hardware used for our client is the same as it will be once our project reaches the production environment. The production environment refers to the infrastructure resources that support the application accessed by the clients. This infrastructure consisted of hardware and software components, including databases, servers, APIs, and external services, scaled for real world usage. The infrastructure required in the production environment must be able to handle large amounts of traffic, cyber attacks, hardware failures, etc. Depending on how many depending on how company wants to release their project, development stages can greatly differ. Some examples of deployment strategies include completely replacing the existing application with the next version, granting early access to a small group of users before releasing to the full user base, canary deployment, okay? Executing A/B tests where different versions of the application can be run simultaneously and new features are toggled on and off using feature flags. Okay. These various approaches allow the development team to test their application in a full production environment, including when the application is released to 100% of the users. For our email client example, the organization will use a phased approach. At first, only 10% of users will be able to use the feature, gradually increasing to 100. Okay, that's interesting. So, types of infrastructure. This article explores various types of infrastructure that have emerged over the years. It also covers their costs and benefits. Until recently, deploying a website required massive amounts of infrastructure. This infrastructure needed a large staff to operate it. Today, managing infrastructure might only involve an account and some settings in a web browser. This article will learn about the types of infrastructure that have emerged over the decades. We'll also learn the costs and benefits associated with each. Let's begin with traditional infrastructure. What is in my throat? Jesus Christ. So, we learned about traditional infrastructure. Traditional infrastructure refers to the way that companies manage infrastructure for web services. With traditional infrastructure, the company acquires, configures, and maintains physical infrastructure components. These components include servers, power supplies, and cooling. Make sense? Traditional infrastructure offers the ultimate amount of control and flexibility, but we learned many challenges arise when managing infrastructure. Two key challenges that traditional infrastructure faces are differences in development environments that can lead to bugs and taking full advantage of the computing resources of each machine. Consider an application that relies on a library. Different machines will have different versions of this library installed, or different versions of an operating system. These differences can lead to inconsistent behavior between machines. Now imagine a server that is only able to host a single application. This scenario is common with a traditional infrastructure approach. The application might have only used 40% of the server's physical capacity. With many such servers, a lot of physical capacity goes to waste. What if there was a way to take advantage of this unused physical capacity and eliminate differences between environments? All right, so enter virtualization. Virtualization technology allows many virtual machines to run on one physical computer. Each virtual machine can simulate the execution of a computer. VMs are distinct environments with their own operating system, dependencies, and users. Virtualization relies on a layer of software called a hypervisor. Hypervisors sit atop the host machine, allocating its physical resources to different virtual machines. With virtualization, each server uses more of its physical capacity. Having fully utilized servers' resources, the number of physical servers needed, requiring fewer servers lowers maintenance, power, and cooling costs. These savings are the main benefit of virtualization. Another benefit is another benefit is the convenience of what in the hell? Give me a sec here. Okay. Another benefit is the convenience of configuring and provisioning virtual machines. Virtual machine management software allows virtual machine configuration with several clicks. Using these tools is more efficient than installing and managing pieces of hardware. Virtual machines also allow for remote configuration. However, there are some challenges with virtualization. For example, it can have some high upfront cost. These costs come from buying virtual machine software licenses and hiring qualified staff. Also, not all machines are capable of virtualization. Virtualization paved the way for a shift in infrastructure management. It allowed us to abstract an application's environment. Yet each virtual machine still requires an operating system. These operating systems each need some slice of the host machine's resources. Let's look at how a successor of virtualization solved this problem. And this successor is called containerization. Such a difficult word to pronounce. uh, containeri- contain Containerization is another form of virtualization. With it, users create virtual environments called containers. Containers share the operating system of the host physical machine. By comparison, virtual machines each have their own operating system, requiring more system resources. Sharing the operating system makes containers smaller and more portable than virtual machines. The technology for containerization has been around for decades, yet it did not become widespread until 2013 with the release of Docker. Docker standardized building and deploying containers. It provided a simple interface for developers to interact with. Containerization brings several benefits. When compared to virtual machines, containers are smaller and faster to create. The smaller size allows many more containers to run on a single machine. The speed of creating containers offers convenience for developers. Like virtual machines, containers reduce bugs caused by differences between development and production environments. A container combines an application and its dependencies into a single package. This combination allows for containers to migrate to different environments with ease. Some challenges with containers include increased complexity and potential security issues. Containers are less isolated compared to virtual environments due to their shared kernel. If someone gains control of the operating system, then they have access to all the containers. Ooh, scary. Virtualization and containerization led to an important shift in infrastructure technology: cloud based infrastructure. Cloud based infrastructure means infrastructure and computing resources available to users over the internet. Usually, a third party company owns, houses, and manages the physical infrastructure. With cloud based infrastructure, applications are entirely separated from their environments. Cloud providers create physical pools of resources. Virtualization allows many instances of an application to run on these resources. A simple interface on the web enables users to configure the pool. Okay, so benefits maximizes the cost saving. It maximizes the cost savings brought by virtualization. It allows specific companies to specialize in physical infrastructure, management, and security. It allows a company to deploy an initial infrastructure that can scale as demand grows. As with other types of infrastructure, cloud based services have several downsides as well. They need an internet connection, which may not always be available. They allow less control flexibility compared to in house infrastructure, and a third party company may have access to some critical data. For most, the advantages of using cloud based infrastructure far outweigh the disadvantages. The majority of companies today use cloud-based services. The biggest providers are Amazon Web Services, Microsoft Azure, and Google Cloud. So we will be going through Microsoft Azure at some point because it's one of the things I need to learn. Cloud-based infrastructure takes away the physical management of infrastructure, but it does not always take away the configuration of that infrastructure. Cloud administrators need to configure the resources provided by the cloud service. The advent of serverless computing removed the need for business to configure Infrastructure. Serverless, huh? Serverless computing is a model for cloud based infrastructure. It allows application development without needing to configure infrastructure. Serverless providers automate many of the resources needed to support an application. These, these resources include databases, networking components, and servers. Serverless applications are still run on servers. However, the provisioning, configuration, and management of these servers are invisible to developers. The most popular serverless model is Function as a Service, or FaaS, with which applications consist of one or more functions. Each function performs a task in response to a specific event. When an event occurs, the cloud provider provisions infrastructure from the cloud. It then uses this infrastructure to execute the function. When the function finishes executing, the resources return to the underlying pool. Okay. This model allows infrastructure usage to match what customers need for their applications. When no functionality is requested, no resources are used to support the application. When usage increases, the cloud provider provisions more infrastructure for the application. The FaaS model begins with some event, such as a button click occurring. Next, virtual infrastructure is allocated and some function loads into the memory. The function then executes and returns a response. Finally, resources return to the underlying pool until needed again. Benefits: developers can focus on business logic without worrying about infrastructure configuration, and infrastructure usage and scaling correlates with user demand. But the downsides are so that it can be more expensive if functions run often. There can be some startup delay if a function was not used recently. It can be challenging to switch from one provider to another, and managing state within a serverless application is more complex. For these reasons, serverless computing is better suited for some apps than others. An app with infrequent surges in demand is an ideal candidate. In time, some of the downsides may get worked out. After all, serverless is still new and catching on fast. It was not popularized until 2014 with the introduction of AWS Lambda. Microsoft Azure Functions and Google Cloud Functions followed shortly after. Serverless computing is the latest trend to change the infrastructure landscape. It won't be the last. The next major shift might come from technology that exists today, or perhaps it has already begun. Cool beans. How much more on this infrastructure thing? Just a little bit. Okay. Camilla just learned that one of the packages used by her team's application has a major security flaw. A new patch for the package is available, which fixes the problem. Camilla is eager to protect customers' data, so she rushes to update the package on production servers. Days later, the team finishes testing a new autocomplete feature. They deploy the feature only to find that it does not work in production. How was this missed during staging? Camilla's stomach sinks. She realizes she forgot to update the package on staging servers. Staging and production were not in sync. Stories like this are all too common. With good infrastructure configuration practices, they are preventable. This article will explore infrastructure configuration and its challenges. We'll also introduce some DevOps tools and practices for infrastructure configuration. Let's start by taking a look at what infrastructure configuration means. So, before an application is deployed, its infrastructure must be provisioned and configured. Traditionally, business staff performed these tasks manually. Provisioning means setting up servers, network equipment, and other infrastructure. Traditional servers provisioning has several steps. Operations team members must acquire a server and install an operating system. Next, they configure the IP address, hostname, firewall, and DNS settings. Finally, they connect it to a network. In today's cloud world, server provisioning means spinning up a virtual machine. There are other types of provisioning as well. Network provisioning means setting up a network component such as switches, routers, or gateways. User provisioning means setting up users, user groups, and privileges. And service provisioning means refers to the provisioning of cloud services. The infrastructure configuration involves customizing provisioned resources. Some example tasks include installing dependencies on a server, updating to a specific Linux distribution, setting up logging, or creating database configuration files. Unlike the initial step of provisioning, infrastructure configuration can be ongoing. Software needs updating, passwords need changing. Further changes to infrastructure fall under the realm of infrastructure configuration. As a company grows, its infrastructure needs to scale as well. Keeping up with infrastructure configuration becomes a daunting task. Let's dive into some problems that arise. So, below are some common problems with manually configuring infrastructure. Costs. Configuration is tedious and repetitive. Large scale infrastructure requires a large staff to configure it, and high staffing needs lead to higher operating costs. Provisioning new infrastructure is time consuming. The time required makes it difficult to scale in response to increased demand. Manual setup is prone to error. Over time, configurations will become inconsistent. These accumulating errors are known as configuration drift. And poor visibility. Due to human error, there is no guarantee that servers are in their desired configuration. It can be difficult to pinpoint these errors later. Okay. So, realizing the flaws with manual configuration, teams began to automate tasks. At first, this consisted of shell scripts that configured servers. Tools such as CSSHX allowed commands to be passed to many servers simultaneously. These steps helped pave the way for how DevOps handles infrastructure. People realized that many common sense development practices were missing from infrastructure configuration. A developer would never change code without checking it into version control. Why was it okay for server configurations to remain untracked? This thinking led to one of the core principles of DevOps, which is discussed in the next section. Infrastructure as code. So that is the act of defining infrastructure in configuration files that are stored and tracked in version control. With IAC, best practices from development are applied to infrastructure. A lot of reading, Jesus Christ. My throat is getting tired. Configuration files should be version controlled. Configuration files should be the source of truth for infrastructure state. Changes to configuration files should be tested before they're deployed, and provisioning and configuration should be automated as much as possible. These practices solve many of the issues with manual infrastructure configuration. Let's explore how. Compared to manual configuration, IAC has the following benefits. It's faster, it's more consistent, it's more visible, and it's cost efficient. IAC tools can be categorized into two different ways. Okay. Orchestration versus configuration management. IAC tools can be classified as either configuration orchestration or configuration management tools. Configuration orchestration focuses on the provisioning of cloud resources. Configuration management focuses on maintaining a desired state in already provisioned resources. Most tools can perform some degree of both tasks, but specialize in one. One example of configuration orchestration tool is Terraform. It has native support for the most common cloud providers. Configuration files are written in either HashiCorp configuration language, HCL, or JavaScript object notation, JSON. These files are then passed into Terraform. Terraform makes the cloud API calls needed to spin up the declared resources. Configuration management tools include Ansible, Chef, and Puppet. These tools maintain a consistent state across cloud resources. They can help automate daily tasks, such as updating dependencies, modifying database settings, or monitoring health. Okay, so declarative versus imperative approach. IC tools take one of two approaches to configure files. In the declarative approach, configuration files describe the desired state of infrastructure. With the declarative approach, the IC tool will configure your infrastructure for you based on this defined state. In the imperative approach, configuration files list the specific commands in a specific order needed for configuring infrastructure. Both approaches are capable of achieving the same configuration. The difference is that the declarative approach focuses on what infrastructure state you want to achieve, while the imperative approach focuses on how to get there. For example, the declarative approach to a peanut butter and jelly sandwich might show a picture of a completed sandwich. A sandwich making robot would then attempt to recreate the sandwich. The imperative approach would list the steps needed to complete the sandwich. Slice the bread, spread the peanut butter and jelly sandwich, blah, 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 blah. Okay. Most IEC tools, such as Terraform and Puppet, fall under the declarative approach. Chef is a notable exception. It follows the imperative approach. Ansible is a tool that allows for declarative or imperative configuration files. Let's look at an example in Ansible and see how both approaches can achieve the same result. Okay, so play, which is written in YAML. Ansible will execute tasks in the order on which they appear in the play. Following play is declarative. It describes the desired state and lets Ansible determine the correct way to achieve it. The play ensures that a database server is always running the latest version. Sure. The first task in this declarative play updates the MySQL server to the latest version. It uses the built-in Ansible package manager called Yum. The second task restarts the MySQL server with 1 second of downtime. Okay. Uses another built-in Ansible module called service. And then below we have another play that achieves the same configuration. This time, however, we'll list the exact shell commands that will configure the server. This makes it an example of the imperative approach. Oh, I see. Okay. So, as is often the case, these two approaches offer a trade-off. The declarative approach is convenient. We don't have to know exactly how to achieve the desired configuration. The imperative approach offers more control and insight into what is going on. This control comes at an expense of convenience. Either way, the use of IC tools helps maintain a healthy and scalable infrastructure. We've come a long way since the early days of infrastructure configuration. Yes, we have. Application infrastructures, lots and lots of reading. Okay. It's been 15 years since Plant Pals first launched their online plant store. In that time, the store's code base has grown to over 10,000 files and 10 million lines of code. The source code is so disorganized that new hires must spend months studying it. When developers finally start making commits, It is difficult to predict their consequences. They, frequent, they frequently introduce bugs in existing features. Simple mistakes can break the entire application. In fact, it is so bad that the team has become afraid of adding features. It has gotten to the point where they only release one update a year. Oof. Plant pals could probably benefit from examining their application architecture. Applications architecture is the framework for how an app is designed, built, and developed. With a more optimal architecture, plant pals would have less trouble scaling and maintaining their application. In this article, we'll explore a I don't know what language was that. Probably alien. In this article, we'll explore the three most common application architectures. These architectures fall on a spectrum, ranging from simple to complex. Let's begin with the oldest and simplest, the monolithic architecture. In a monolithic architecture, an entire application and all its features live within a single code base. The application is written in a single language. When developers add features, they must redeploy an entire application. This is the architecture currently used by PlanPals. Monolithic applications, or monoliths, have been around since in house infrastructure was the norm. Since then, several other types of architecture have also become popular. Still, a monolithic architecture has its benefits over the types. It is speedy, it's simple in deployment, and simple to test. The drawbacks are that they have a single point of failure, they have inefficient scaling, and complex database. Despite the advent of newer architecture, monoliths still have their uses. A monolithic architecture can be a good choice when developing small internal applications or starting a large application and then switching architectures when complexity increases. Okay. So, this is just one thing. Then we have N-tier architecture. N-tier architecture splits an application into several layers. Oh yeah, I think we learned something about that. Yeah, presentation layer, logic layer, data layer, and so on and so forth. Yeah. We learned about this. Separation of concerns, better scalability, but several points of failure and complex deployment. So best used for large internal applications or enterprise applications when other architectures are deemed undesirable. And then we have microservice architecture, which refers to an application where features are spread across different services. Each service is responsible for a tightly defined component of business logic. Services should aim to have smaller, independent code bases. These aspects make microservices a more granular approach than architecture like N-tier. Let's say our friends at PlantPals want to switch from their monolith to microservices. They would create a microservice for each individual component of their online store. One service could handle product searches, while another could handle payments. Each service would directly access only its own data. However, they can also communicate over a network. In the end, they might have an architecture that looks something like this. Okay. So, benefits: resistance to failures, superior scalability, diverse technology, and smaller code bases. But the drawbacks are slower initial deployment, complex deployment, and difficult testing. The use cases, they're complex to set up. However, they provide many long-term benefits over other architectures. So they're generally used for one purpose: large enterprise applications. Netflix, Facebook, Amazon, and Google are just some popular applications that deploy microservices. Quiz. In IC configuration files, the blank approach simply describes the desired state of infrastructure. Declarative. and imperative. Yes. Match the following types of infrastructure to the correct descriptions. This type of infrastructure involves storing and maintaining servers on company premises. Oh yeah, such small companies. Why they are not using monolith for everyone. Hey Vinci, welcome back. How's it going, man? What course is this? It's the same course still, but we're doing a different unit, which is DevOps Fundamentals. What have you been up to, Vinci? Haven't heard from you in a long while. So this says in-house. This type of infrastructure involves making computing resources available over the internet. Cloud base and invisible to the team. Serverless. Learning DevOps. Lol. Been busy with work as well. What are you lolling at? What's the problem about learning DevOps? Explain yourself. Busy with work. I see. Working through a coding challenge. Cloud resume challenge. Cloud resume challenge. Huh. What's it about? More consistent. Match the following benefits to the correct infrastructure configuration methodology. Consistent, more cost effective, decreases reliance on tools, and most flexible. I think it's like this. Nope. Infrastructure as code seeks to automate. Automate. Then tested for validity. These configuration files will be the source of truth for our code. Wait, no. Or our infrastructure state seeks to automate provisioning and configuration. Yes. In software development, unblank is a subset of blank resources used to execute a program under specific constraints. So an environment is a subset of infrastructure resources. Holy crap. This is an environment where test cases are executed against the application as a whole. So, probably testing. Live application runs and is exposed to real users. Production mirrors production as closely as possible. That's staging. Local environment. So that's development. Where features are merged into a unified codebase. Integration. In web development, blank is the set of hardware and software components on which web applications are developed, tested, and deployed. Traditionally, it has been managed by companies. Yeah. What is the key difference between a virtual machine and a container? A virtual machine requires its own operating system, while a container shares the operating system with the underlying host. Yep. Match the following application architecture to the correct descriptions. This type of application is split across several layers, which each run their own server. The layers can grow quite large. This is microservice, I think. Distributes small components of business logic into their own services. No, this is microservice. This is the N tier, and this is monolithic. Acquiring and setting up a server is an example of infrastructure. Configuration or provisioning? Configuration. While updating application dependencies is an example of... No, it was provisioning. Yep. Oh, god damn it. So much reading today. Monitoring. Holy baloney. So we have system health, and then we have DevOps processes. Okay, let's... let's finish monitoring, actually. Yeah. So, in DevOps culture, feedback loops are critical to improving processes and fixing issues. Monitoring is feedback coming from our code deployment environments. Monitoring refers to the set of technical practices and tools that tell us what is happening in the system. Monitoring is achieved by defining and exposing the measurements we want to see while the system is running. As a result, we gain deeper insight in our system's operations. We can identify issues sooner, and we can provide longer lasting solutions. Throughout this article, we will describe some of the core concepts of monitoring. Okay. Goals of monitoring can provide all sorts of business value. After an update of the payment system, the number of servers handling payments drops. The number of servers handling payments drops. The monitoring system sends out an alert to engineers. Order processing starts slowly, but engineers begin finding the issue. Monitoring is a critical way of learning that something is wrong with the health of the system. Without monitoring, the company might not know of a problem until customers complain. Orders not going through cost the company money. Monitoring can inform the engineering team as soon as a problem starts. So, what happens next? Dab is an engineer assigned to the order processing issue. She can open up the logs of the downed servers and find out what was happening before the crash. Last message in each case is the system trying to talk with an authorization provider. She can locate the issue. The update had accidentally changed the authorization request format. She puts the fix in. Monitoring also helps determine why a system is failing. Using logs and metrics, engineers can investigate what is happening within the system. The ability to see inside a system leads to more informed solutions, but not all issues are resolved by individuals. So the order processing issue has been resolved, but graphs are indicating high usage of server CPUs. The system automatically deploys more servers and balances a web traffic across them. Monitoring can help stop problems before they cause a failure. Through monitoring our systems, we can detect strains early and implement automation to respond as necessary. Okay. So, what should we measure? request metrics such as number of incoming requests, response time, or error responses. We can measure server metrics, which is hardware usage and uptime. We can measure observability. Measuring monitoring. Good monitoring seeks to create observability in the system. Observability is the ability to use the system's information to locate and fix a problem. Some key questions we can investigate to measure observability include: how long did it take to notice a system issue? And how long did it take to locate the cause of this issue? We also have alert metrics such as false negatives, false positives, and unactionable alerts, which is what? The type of alert has little to do with the problem and doesn't need anything done. Like false negatives, we should reduce or delete unactionable alerts. Okay, so unless useless or incorrect alerts add to the chance that valuable alerts will be ignored or unseen, keeping our alerts at a high quality to ensure that each is given proper attention. Sure. Resiliency. Practices for making systems that continue to perform under adverse conditions. From an unknown location, behind layers of virtual network providers, an enter key is pressed. Millions of requests begin bombarding the servers. It's a classic DDoS attack, DDoS cyber attack. The company's servers start to buckle under the traffic. Customers first see the web pages load slower, then slower still, and then they don't load at all. How can we prevent this? When it comes to software systems, time really is money. Unexpected downtime can result in a loss of transactions, decay of customer trust, and a host of other issues. Failure will always be part of our systems. However, with the right preparations, we can build systems that are resilient to failure. In this article, we will introduce resiliency, a system's ability to continue to perform despite experiencing problems. Creating a resilient system allows our services to be highly available, which means our customers can access our functionality a vast majority of the time. Mm. So we have system threats such as internal failures, which is hardware breaking or firmware becoming outdated. We have external failures such as cyber attacks or like DDoS or SQL injections. Okay. Hey, Poggle. How's it going? How's your Wednesday so far? Failures will always happen. Failures will always happen. Could not be a more humbling statement in the entire universe. Nothing's broken today as of yet. Oh, you're the first one today who doesn't have something broken. Tiberian, wait, what was Tiberian? Uh, wait, where was the chat? I don't remember. Yeah, he had a broken pull request or something. Then Happy is dealing with a broken server or something. Checkham is dealing with his broken sense of priorities, just playing World of Warcraft instead of learning coding. Uh, what else? I'm dealing with a broken brain. So yeah, that's fun. So I'm glad at least someone isn't experiencing breakage. Wow, the productivity killer, indeed. He said he did like 36 hours of WoW in 3 days. But at least he now has autonomous autonomous mana recovery. uh, God, I'm so tired. Ugh. I assume you're at work, right, Poggle? How's the learning going anyways? Well, we finished databases. We jumped momentarily back into JavaScript testing. Writing unit tests was fairly interesting and pretty fun. Server testing was confusing as all hell, so we just kind of glossed over it because I don't foresee us needing it in any capacity anytime soon. And now we're just brushing over the last few topics of our roadmap, or at least the Codecademy part of our roadmap, which is DevOps Fundamentals, and we'll jump into GitHub momentarily as well. Made a bacon sandwich with some Korean barbecue sauce, so eating that right now. Interviewers love bringing up TDD. Yeah, they do. I don't know, like it's pretty fun, but it seems more tedious than writing the code itself. So, I don't know. Yeah, it does save you in the long run. That's true. Bacon sandwich with some Korean barbecue sauce. I had ribs for lunch. Leftover ribs from yesterday. That was tasty. With some radish. Mmm. Uh Had a pretty long morning meeting, so didn't get a chance to make breakfast. I see. I kind of hate making breakfast, to be honest. I usually don't make anything. I just typically have a cup of coffee and I like eat a pear. And that's my breakfast. Then I whip something quickly for lunch and then have a really big dinner. And that seems to work for me. It was more like a brunch. And I don't know, the schedule of mine of eating has helped me to lose weight as well. Like I feel like I think I lost like 13 kilos since New Year just by following this sort of way of eating. Yeah, I needed to lose a little bit of weight. When I started, I think I was like 97 and I am 84 now. Yeah, thank you. Uh, once I start having a little bit more financial freedom, I'm thinking about hitting the gym as well. The problem is like my usual gym has hiked up their rates quite a bit, and it is much further away because I've moved. So going back to them is no more, it's not economically viable anymore. But they had a great complex. They have like the gym, then they have like a pool. They also have saunas and everything. So it was pretty fun. You go to the gym, then you hit the pool, then you go to the sauna. It was like pretty nice. Yeah, and then you leave like floating. It was a really good feeling afterwards. Just leaving at home, still saving as much money as possible. I see. You'll get there one day. I have no doubt in my mind. Gotta move out with the parents soon, though. You mean, oh, move out of the parents? I mean, if they're not pressuring you, don't force it. Enjoy the freedom that comes with living at your parents. If you don't have any other like problems or like if they're not forcing you out, or if you like get together, get along well with your parents, don't force it. Trust me. Pretty much zero bills, saving 8% of salary. Yeah, that's like the biggest advantage. Also, maybe sometimes not having, most of the time, not having to worry about what to make for dinner. That's a huge advantage. Yeah. Like it's such a hassle too, Jesus. I don't know. We settled on just ordering food for a week. We like pre-plan our meals a week in advance. Then we ordered bulk order from like a delivery service that brings us the ingredients. Then it's much more manageable. You don't have to think every day. You just have to do the thinking once a week, which is which has saved us so much headache. Oh yeah, okay. I don't. Hmm. How should I put it? I like cooking, but I hate cooking. That makes sense. Like I like the process of cooking, but what I don't like is like the afterwards of cooking, where you have to like do the dishes, put everything away, blah blah blah. It's one of the main reasons why I got a dishwasher. I could just toss everything in a dishwasher and be like, okay, done. Dishwasher's king. Yep. Like when we were modeling our kitchen, we since we have a very small kitchen, like we had to sacrifice some things just to get the dishwasher. And we spent so long modeling the kitchen. At first, we tried ourselves because like it's not that hard to use the software that models like rooms and whatnot. So I was trying to make it work, but the problem is that you can't really like get the furniture that is in the modeling unless you're in the modeling software, unless you're like ordering everything custom, which was not an option because the bill would have been like triple the cost otherwise. So we settled for IKEA modeling thing, and they have their own thing that they order. They model every with whatever they have. So we went there and we spent like 4 hours, I think, with a consultant just sitting there, pretty much modeling everything to our liking. Yeah, I mean it's pretty decent quality too. We pretty much got all our furniture from IKEA. It's not really that expensive. Like some things can be, but the quality is decent enough, I suppose. It's probably not the kind of quality that would last through generations. Like back in the day, you buy a chair and you can like that chair gets inherited by 7 generations of grandchildren. Also cheap enough that you find replacing down the road. Well, yeah, yeah. The only custom, well, okay, not really custom thing, but like a thing that we didn't buy from IKEA is probably our Murphy bed. So like this couch right here, the cushions get moved away, and behind it there's like a wardrobe looking thing that just kind of lowers down and it becomes like a double bed. Help to save space. Yeah, because the apartment is kind of small, but so space saving was like our primary goal, especially since we were like considering getting a dog down the road somewhere, and you do need a little bit of space for the dog to roam a little bit. One thing I've spent money is on my mattress. Oh yeah, that's that has been a game changer for us as well. Because like when we were renting, we were the apartment came with a mattress. It was garbage. It was like a spring mattress, but the springs had somewhat worn out by the time. After that, while we were doing renovations on this apartment, we moved into my mother-in-law's mother's apartment where we kind of laid on just a couch that becomes a bed, which was extremely uncomfortable. So as soon as we were able to move into here, we went mattress shopping and just bought the fanciest mattress our budget could allow, and it's been such a worthwhile purchase, both for the sleep quality and the quality of the mattress itself and everything else. It's comes with an expensive mattress is worth. Yeah, definitely. Especially for if you're a light sleeper like me, because I am such a light sleeper. So having a comfortable bed is just a must. Uh, okay. Think let's take a little break. 10 I think 10-minute break should suffice, and then we'll come back for the rest of this article. So I will be back. Okay. Let's get this B-ish done. Oh, the weather outside is turning south. It's getting cloudy real fast. Okay, so methods for resiliency. Failures will always happen. Resiliency is about making our systems able to handle failure well. Two strategies for doing this are reducing the workload and spreading the work around. Isn't it the same thing? But I think it's the same thing. Okay. Reducing the workload. We can start by reducing the requests our system needs to process. We can minimize system work via two mechanisms: input validation and caching. Input validation involves running checks on requests incoming into the system. These checks will allow us to throw away malformed or malicious requests. Validation prevents these bad requests from reaching our inner systems. And caching, some of these regular requests that come into our system might return the same results again and again. Caching stores the commonly requested results, reducing the work necessary to resolve similar requests. Caching separates requests into two types: cache hits, those that are already in the cache, and cache misses, which need to work from the application server. Okay. And then we have spreading the work around with automatic scaling, which allows us to use more or fewer servers based on the need. Monitoring can detect when our systems is encountering a high or low amount of traffic. When monitoring detects a high amount of traffic, our system can add more servers. Upon low traffic level detection, automatic scaling can reduce the number of servers. Adding or removing servers isn't enough. We need a system to direct the appropriate amount of traffic to any servers we have. Okay, so we can do that with load balancing, which distributes requests across many resources. With two servers, a load balancer might send every other request to each server. Okay. We've discussed some of the primary ways to build resiliency into our systems, but how do we know we've done a good job? let's discuss some methods for measuring how well our resiliency systems are working. We want to be able to estimate how our systems will perform under adverse conditions. There are three approaches we can use to measure the resiliency of our systems. Each approach provides a different degree of accuracy. So we have analysis of infrastructure. Statistic infrastructure analysis is the easiest but least accurate method of measuring resiliency. We make assumptions about system performance based on our infrastructure specifications. Imagine we have 3 servers, each capable of handling 3,000 requests per second. But then we then reason that our system can handle 9,000 requests per second. But when we connect everything, we find our system starts to struggle at 8,000 requests per second. Unfortunately, the conditions our system can handle on paper often differ from reality. While this kind of analysis can produce a ballpark figure, we shouldn't rely on it for exact amounts. Okay, we have controlled chaos then. Remember, we want to know how our system will perform under difficult circumstances. It makes sense then to create some problems on purpose to see how our system responds. Let's take a look at some ways engineers test the resiliency of their systems. So, penetration testing, trying to exploit security vulnerabilities by simulating cyber attacks. Penetration testing gives us a chance to see how our systems might respond to a malicious user. Using penetration testing allows us to identify holes in our security that we need to fix. Load testing, replicating situations in which the system is under heavy use. Load testing might simulate millions of customers trying to access the site all at once, which can help us identify areas in which the system will break under the real world conditions. And then chaos engineering, where we will purposely cause system failures. The engineers might unplug a server, take down a critical API, or disconnect storage. These actions reveal how our systems will respond in failure scenarios. We can use these insights to identify weaknesses and strategies for these solutions. The most accurate predictor of how systems react to problems is how they respond to real problems. We can use aspects of monitoring to measure our system's response to problems. Some important metrics might include uptime, recovery speed, request resolution time, and request failures. So the use of metrics and logs to watch and understand a system is the use of metrics is monitoring, while the ability to use a system's metrics to identify and resolve issues is observability. A system's resiliency is its ability to recover when failures occur. The act of analyzing incoming requests for correctness, that is input validation mechanism for evenly distributing requests across multiple instances of an application. We call that load balancing. And then caching is the third one. Which of the following metrics is a reflection of observability? Is a reflection of observability. Number of incoming requests, uptime, latency, or actionable alerts. Actionable alerts? Yeah. The frequency of actionable alerts is a good indicator on how easily a system alerts can be acted upon. Match the following metrics to the description of their utility. Useful for measuring the amount of traffic and thus how much infrastructure to allocate. So, useful for understanding and making decisions about physical server utilization. That's probably hardware usage. Useful for measuring the number of failed requests as well as whether these failures are happening in the client or server side. Something like that. Yep. Match the following system threats to the examples of them. A server hard drive breaking would be an example of this type of threat. So that is the internal failure. DDoS is a attacks and external failures. Resiliency can be measured by determining how quickly a critical failing service is reported and the degree to which critical services are available. Oh, crap. Oh, well. DevOps automation. Learn about how automation is used to enhance the DevOps lifecycle. Rama is overseeing a web application for a new grocery delivery service. The developers are passing their source code to the operations team members. The operations team manually set up the servers and deploy the code. This process can take weeks, and deployments keep failing due to minor errors. How can we improve this workflow? In this article, we will be answering the following questions. What is DevOps automation? Why use automation? What can be automated, and what tools do we need? So, automation is using tools or programming to perform repetitive and time-consuming tasks. When compared to doing the work by hand, automation is faster, less prone to errors, and cheaper. What can we automate? We can integrate automation into nearly every aspect of software development. Let's take a look at some of the ways automation can play a role in software development. Many project planning tools such as Jira, Monday, and Slack have automation features. These features allow recurring meetings and stand-ups to be auto-generated, notifications to be sent to team members when items are completed, and more. One of the main areas of automation in DevOps is building, testing, and deploying our code. The main practice of this is continuous integration and continuous deployment. CI/CD tools allow for automated building, testing, and deployment of application code. CI/CD helps ensure a working prototype is available and running with the most recent changes. Automation is useful for processing logs and collecting metrics when monitoring software. Visualization tools allow for the processed data to be converted to interactive diagrams. Okay, so we have Jenkins, GitHub, and Gradle, or Gradle. Gradle, I think. Focus on building and compiling. While they have their differences, all three automatically build, test, and deploy code. Learning these tools allows us to automate aspects of our DevOps workflows. When learning one tool, keep an open mind about learning the others as well. Each DevOps team will have their own DevOps automation workflow. Having flexibility with our tooling can be a great asset. How much more is there to it? I think this is the last one. Yeah, okay. Continuous integration. The problem. Daryl and his team are developers. Oh, Daryl and his star team of developers are working on new features for their popular mobile game. Each of the developers have been working on separate branches for the last week. Now they are all confident in their code and are ready to merge in their changes. They begin the merge process and see their console fill with conflicts. Daryl sighs. He had plans for this weekend. This could have been prevented if they had used continuous integration approach. So continuous integration, or CI, is a practice that consists of two main components. Merging source code changes on a frequent basis and building and testing the changes in an automatic process. Combination of these components ensures new additions are built and tested often. CI practices can be implemented on their own. However, they are often mentioned alongside continuous delivery and deployment. The combination of continuous integration, delivery, and deployment is called CI/CD. CI often requires changing the way we work with source control management. Let's take a look at why CI might make us want to move away from traditional feature branch development. In the past, traditional source control management approaches used long-lived branches. These branches were merged only once a feature was completed, hence the name feature branch development. This works well for smaller projects or for a single developer. However, issues arise with bigger projects. There are long review periods for relatively larger feature branches, and there could be many conflicts when merging large branches into the main repository. So, the goal of CI is to frequently merge, build, and test code changes on the main branch. Feature branch development cannot be the solution due to the slow cycle of merges and relatively large branch sizes. And we have trunk-based development is frequently merging small changes into the main branch or trunk. Some of the benefits of trunk-based development include discovering problems early, known as shifting left instead of at the end of the large merge attempt, and small changes mean fewer conflicts and simpler fixes. CI combines trunk-based development and the automation of building and testing. After each small merge into main, the codebase is automatically built and tested. This process ensures that the repository always has valid code ready to be deployed. Now that we have an understanding of CI, let's look at a few tools which can help with automation. So, popular CI tools, blah blah blah, configured to run automated tests and notify developers of any problems. So we have Jenkins, GitHub Actions, or Circle CI. Implementing CI in a project has a few steps. Make sure that the project is using one main source branch. Pick one of many CI servers to control automatic builds and tests. Configure the CI servers to trigger automatic builds when merges occur. Develop tests and configure the CI server to run them. Also, set up notifications for build or test failures. All right. What? Where did you come from? Continuous delivery and deployment. Jaden and their team have finally decided to follow continuous integration practices. CI has improved their application's speed and stability. Jaden has the newest version of the web app tested locally but is waiting on integration tests. Afterward, if no errors occurred, they must manually deploy the app on a production environment. Although CI sped up the development and reduced bugs, manual deployment wastes a lot of time. Jaden and their team can add continuous delivery and deployment to increase their speed and effectiveness. In this article, we will learn how continuous delivery and continuous deployment increases project speed and quality. We will also learn how these practices work with CI to form the CI/CD pipeline. So, continuous delivery automates the preparation of software for deployment. Continuous delivery begins where CI finishes, with the application built and tested. Automated processes move the application throughout staging environments while executing more tests. Continuous delivery ensures the newest version of the project is ready for production. When the application moves between environments, the differences in how these environments were configured can cause problems. For example, code may build in an code may build in a development environment but break in staging. These breakages could be due to differences in dependency versions or other issues. A practice called containerization can reduce these differences. Containerization packages the application and its dependencies into a container. This packaging allows the entire container to migrate between environments with ease. Adding containers to continuous delivery simplifies the application movement across its environments. After continuous delivery, the project has been built and tested in production-like environments. The project would still need to be manually deployed to a production environment to be visible to users. This step can be automated using continuous deployment, which automatically deploys an application to the production environment. Continuous integration and delivery must prepare the application before continuous deployment. Throughout continuous deployment, customers will always have the newest version of the application. When using continuous deployment, in combination with continuous integration, rapid merges take priority over completed features. We can use feature flags and dark launches to prevent users from accessing incomplete features. So, feature flags are a coding technique that prevents users from accessing certain features. We can implement feature flags with simple conditional statements, such as an if statement. We can change the condition once the feature is ready to be released. But what if we want only a specific group of users to access a service? Then we do a dark launching, which is a similar feature to flags, but certain users have access to new features while others are kept in the dark. Dark launching uses features flags, but specifically with conditions based on the type of user. Once a small group of real users tests the new feature, it can be gradually released to the users. Implementing continuous delivery and deployment can further improve the automated processes started by continuous integration. Together, these three processes from the CI/CD pipeline, also referred to as deployment pipeline. Okay, so continuous integration consists of frequently merging, building, and testing. CI combined with continuous delivery and deployment forms the CI/CD pipeline. Let's walk through the full CI/CD process. Keep in mind that CI/CD processes are automated. So a developer makes a change and commits their code. The change is merged by CI. CI builds the changed code base and runs the initial tests. The delivery part of CD puts the build onto test and staging environments. Another set of tests are run by the delivery part of CD. Then the deployment part of CD moves the build from staging to production. Customers can potentially see the changes in the product. Okay. So although the pipelines may seem complex and require a lot of setup, we received many benefits, such as with less time needed to devote to these tasks, team members can focus on developing. Throughout monitoring, developers can use feedback from the pipeline to make further speed and quality improvements. Frequent builds allow CI/CD tools to have a record of many older releases. When an issue occurs, developers can quickly revert to one of these previous versions. Developers can then fix the issue, and a new release can go through the pipeline. Okay. So to use CD in a project, we can do the following. Make sure that CI practices are already being used in the project. Configure the CD server to deploy builds, to test, and staging environments automatically. Write post-deployment tests which trigger after continuous delivery. Monitor the deployments and alert if any problems arise, and configure the CD service to deploy to a production environment if no issues occur. Holy crap, that's a lot of reading. Okay, CI/CD pipeline begins with rapid merges into the code repository and initial tests during CI, continuous integration. Next, the build is moved to staging servers and tested again during continuous delivery. At this point, the application is ready for production. Continuous deployment automatically moves the build. What comes first, deployment or delivery? Deployment comes last. Okay. Which is not part of the continuous integration. Building the project, running tests, deploying the project, monitoring. Continuous integration. CI, running tests. Running tests? Deploying the project. Yeah. Match the best practice terms to the definitions. Prevents users from seeing unfinished features by disabling parts of the code. That's feature flags. Allows certain users to see new features in the project while others cannot. That is dark launching. provides standardized environment to be used across continuous integration. That's containerization. Main source repository is maintained with small changes and frequent merges. That is feature branch development. Nope, I'm wrong. So many terms to remember. Before, continuous delivery can be used in a project. Continuous integration must be incorporated first due to rapid merges, builds, and tests. Yes. One of the most popular automation tools designed for continuous integration, delivery, and deployment is Jenkins. Match the CI/CD terms to the definitions. Frequent merges into a single code repository after building and automated tests. CI. Preparing a project to be deployed on a production server by moving the project to intermediary servers with tests. That's delivery and that's deployment, which is not a benefit of using DevOps automation. Rigid project structure. Yeah. Oh. And what is the process of using tools, scripts, and other software to perform aspects of software development and operations? It's automation. Okay, so we now have a glossary understanding of what DevOps is. To an extent. At least I won't be like a goat staring at a newly painted gates when I start working in a company. With people throwing terms like continuous development and whatnot. Okay, so we're done with DevOps Fundamentals. And the last thing to do on Codecademy, or Codecademy, Codecademy, is to take a look at GitHub. We have 2 parts to GitHub, so we're probably not finishing today. We have workflow, how to backtrack, introduction to GitHub, markdown. And then part 2 entails branching, teamwork, best practices for repositories, and collaborating with the community. Well, this seems like a lot of reading as well. There's some projects as well. Interesting. Okay, let's take a look. Wait, actually, let me open a window. It's getting kind of hot in here. Okay, let's take a look. GitHub or Git and GitHub part 1. Yeah, I'm yawning too. Yeah, you're tired too, Thor, huh? You're tired too. Yeah, me too. Okay, so the goal of this unit is to introduce you to Git versioning technology. Understanding Git is a crucial tool in your developer toolkit. But don't worry if it doesn't stick right away. Practice is crucial with Git, which is why we're introducing it early in the path. Additionally, you understand how to take the repositories on your computer and put them online with GitHub. Having your work on GitHub will be important when you apply for jobs, and crucial to that will be having a solid readme.md, which you'll write with Markdown. After this unit, you will be able to version control projects using Git, backtrack in Git, host a codebase online using GitHub repositories, and use Markdown to author a good readme.md file. Okay. Oh, we have a video. Okay, let's take a look. Gotta be efficient. Or stop eating your leg. Yeah, I'm talking to you. All right, well, let's take a look at some theory and exercises. Okay, so Git is a software that allows you to keep track of changes made to a project over time. Git works by recording the changes you make to a project, storing those changes, then allowing you to reference them as needed. We'll learn Git by using it to help us write a screenplay called Harry Programmer and the Sorcerer's Code. Okay, we'll get started by taking a look at the screenplay project. In scene1.txt, add this text. Then press enter to create new empty line. Um, sure. What? Oh, okay. Now that we've started working on the screenplay, let's turn to the Sorcerer's Code directory into a Git project. We do this by writing git init. The word init means initialize. The command sets up all the tools Git needs to begin tracking changes made to the project. Okay, so we just do git init, internalized empty Git repository in home, blah, 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 blah. Okay. Well, now we have a Git project. Git project can be thought of as having three parts: a working directory, where you'll be doing all the work, creating, editing, deleting, and organizing files; a staging area, where you'll list changes you make to the working directory; and a repository, where Git permanently stores those changes as different versions of the project. The Git workflow consists of editing files in the working directory, adding files to the staging area, and saving changes to a Git repository. In Git, we save changes with a commit, which we will learn more about in this lesson. Take a look at the diagram. Before we move on, it will help to be familiar with the three parts of the Git workflow. Okay, working directory. We make changes to files. When looking for gold. Then the staging area, where files are ready for a commit, and a repository. Changes are saved to repository as a commit. All right. As you write the screenplay, you will be changing the contents of the working directory. You can check the status of those changes with git status. So from the terminal, check the status of the Sorcerer's Code project. In the output, notice the file in red under untracked file. Untracked means that Git sees the file, but has not started tracking changes yet. Okay, so init_test.rb and scene1.txt. Nothing added to commit, but untracked files present. All right. In order for Git to start tracking scene1.txt, the file needs to be added to the staging area. We can add a file to the staging area with git add file name. So git add scene1.txt. Check the status. All right, now we have a file in the staging area. So use git rm ---- cached file to unstage. All right. Git diff. Now you know how to add a file to the staging area. Imagine that we typed another line in scene .txt. Since the file is tracked, we can check the differences between the working directory and the staging area with git diff file name. File name is the actual name of the file. If the file name of my file was changes.txt, the command would be git diff changes.txt. Okay, so we add this here. I should have known you would be here, Professor McGonagall. From the terminal, use the new command to check the differences between the working directory and the staging area. Okay, so git diff scene 1.txt. Fatal, ambiguous argument. Unknown revision or path not in the working. Okay. Add the changes to the staging area in Git. So we need to add it again. We can't see the differences still. Use to separate paths from revisions. Okay, I think it's broken or something. Git commit is the last step in our Git workflow. A commit permanently stores changes from the staging area inside the repository. Git commit is the command we'll do next. However, one more bit of code is needed for a commit. The option -m followed by a message. Here's an example. Standard conventions for commit messages must be in quotation marks, written in the present tense, should be brief, 50 characters or less, when using -m. Okay, so git commit -m, and then we write something like add second line of screenplay. Git log. Often with Git, you'll need to refer back to an earlier version of a project. Commits are stored chronologically in the repository and can be viewed with git log. Okay, so from the terminal, log a list of your commits. In the output, notice. Okay, git log. .lig. Log. Add second line of screenplay. Okay. So a 40-character code called a SHA that uniquely identifies the commit. So I assume it's this. This appears in orange text. The commit author, yes, date, and the message. Cool. Generalizations. We have now been introduced to fundamental Git workflow. You've learned a lot. Let's take a moment to generalize. Git is the industry standard version control system for web developers. Use Git commands to keep track of changes made to a project. Git init creates a new Git repository, Git status, add diff commit log. Cool. What is the purpose of Git staging area? To stage file changes for a commit, to list files you don't want to get track, to list notes about your project, to show a list of your project's comments, to stage files for a commit. The output below is typical of which command? Git log. Why use git? Keep track of changes made to a project over time. What does git init do? Initialize a new git project. Command git status shows. Untracked files and file changes staged for commit. Where in Git do you typically create, edit, and delete? What the hell? Where in Git do you typically create, edit, delete, and organize project files? In the working directory. What's wrong with the code below? It's not in quote marks. In Git, a commit saves every file in your working directory, temporarily stores changes from staging area into a repository, permanently stores changes from the staging area into the repository. In the code below, what will you replace file name with? The file you wish to add to the staging area? Yeah. Okay, so project. Initialize a new Git repository. So git init. Check the status of the repository. Git status meal regiments.txt. Add meal regiments to the staging area. Git add meal regiment.txt. Regimens. Make a commit. Git commit -m. Let's do initial commit. Include this new info into meal regiments. Sure thing. All right, so git add. Actually, I can just do this. Check the status. Modified. Make a commit. Git commit -m. Add a meal regimen for long-tailed chinchillas. View your git commit history. Bam. There's 2 more animal reports. Include each in meal, making a new commit for each animal added. Right, so we just do this. Should be 4. How did that become 3? I don't know. We do git add and git commit -m. Add a meal regimen for... Oh, crap. Okay. We made a mistake. How do we remove from the staging area? Use git reset head to unstage. Wait, git status. reset head to unstage. So if we do git reset head, meal regiments.txt, that should unstage it. Okay, so now we can actually change it to the thing that it's supposed to be, and then add it again. We check status, nothing's been staged yet. So now we add, and now we git commit. Add a meal regimen for poison dart frogs. Yes, and then finally the last one. We do another add. And another commit for Western Lowland Gorilla. Now, if you do git status, nothing to commit. And if we do git log, we see 4 commits. Okay, cool. Easy peasy. SnapFit robots. Now you had more practice with Git workflow. Let's solidify your skills even more. In this project, you will be working on assembly instructions for SnapFit robots, a build-it-yourself robot company. Okay. So we do git init. Check out the status. Git status. We have a couple of files. Add each file to Git staging area. So git add disclaimer.txt. Git add instructions.txt. Git add warranty.txt. All right. Check the status again. Boom. Make a commit. Initial commit with disclaimer, instruction, and warranty files. Boom. Okay, view your git commit. So git log. No, git log. Sure. Seems good. Include this line in disclaimer. Oh, not this line. This line. To git add disclaimer. Yeah. Now commit. Battery life, do not leave robot battery. Okay, so add battery disclaimer. Git log. Initial commit with disclaimer, instructions, and warranty files. And also battery disclaimer. Okay. Seems simple enough. And so far, at least. When working on a Git project, sometimes we make changes that we want to get rid of. Git offers a few eraser-like features that allow us to undo mistakes during project creation. In this lesson, we'll learn some of these features. One sec, I'm gonna close the window. It's getting cold now. Okay. So Git offers a few eraser-like features that allow us to undo mistakes during project creation. In this lesson, we'll learn some of these features. So, you are in a Git project titled Hamlet Prince of Denmark. In Code Editor, you'll be working on scene 5. Here, Hamlet encounters the ghost of his father. Add this text to the file. Or from the terminal, add the file to a staging area. Git add scene 5.txt and commit the changes with a good commit message. Add second ghost line to script. Oh crap. What did I write? Commit. Commit. There we go. All right. So in Git, the commit you are currently on is known as the head commit. In many cases, the most recently made commit is the head commit. To see the head commit, enter git show head. Show head. Boom. What do we got here? We got the date, the author, and what was added, I assume. The output of this command will display everything the git log command displays for the head commit, plus all the file changes that were committed. Sure. Checkout. What if you decide to change the ghost's line in the working directory, but then decide you wanted to discard that change? You could rewrite the line to how it originally was, but what if you forgot the exact wording? The command git checkout head will restore the file in your working directory to look exactly as it did when you last made a comment. File name again is the actual name of the file. If the file is named changes.txt, the command blah blah blah. Okay. So change the ghost's words in some way. Okay. Boom. It's the same. It's the same way. Oh no, it's not. Okay. From the terminal, use git diff to see the differences between scene 5 as it appears in the working directory versus how it appears in your last commit. So git diff scene5.txt. Okay. Use new git command to restore the file in your working directory to look as it did when you last made the commit. So git check out head in scene5.txt. Didn't really change anything, but sure. More git add. The Hamlet repository we are working on contains 5 files. In Git, it's common to change many files, add those files to the staging area, and commit them to a repository in a single commit. For example, say you want to change the character Larry to Lartaise in the script. The name currently appears in 2 files. After you change the name in both files, you can add the changed files to the staging area with git. Oh, you can just list the files. Okay. Note the word blah, 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 blah. Okay. So the code editor is open to scene 3 and scene 7. Change it to Laertes or whatever. Blah, 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 blah. I think that's about it. Now the same here. This and this. All right, so we do git add scene 3.txt and scene 7.txt. Git status, and both of these files are in there. Git reset. Great. Files you've added to the staging area belong in the same commit. What if, before you commit, you accidentally delete an important line from scene 2? Unthinkingly, you add scene 2 to the staging area. File change is unrelated to Larry Laertes swap, and you don't want to include it in the commit. We can unstage that file from the staging area using git reset head file name. Command resets the file in the staging area to be the same as the head commit. Does not discard file changes from the working directory, just removes them from the staging area. No. Don't dig at your bed. Yeah, use your mouth to get the toy. Don't use your long ass nails and destroy the bed. Okay, let's make a mistake on purpose. Delete any line and click run. From the terminal, add scene 2 to the git staging area. Scene2.txt. I said 2. I said 2. I said dash. I said scene. Jesus Christ. 2. I cannot type for the life of me anymore. There. Now check the status of the Git project. All right, so we have scene 2, 3, and 7 in there. So git reset head scene2.txt. I see. So these are in the staging area. we can now easily commit. So git commit -m a good commit. Okay. Git reset 2. Creating a project is like hiking in a forest. Sometimes you take the wrong turn and you find yourself lost. Just like retracing your steps on that hike, Git enables you to rewind to the part of the project before you made the wrong turn. You can do this with git reset commit SHA. This command works by using the first 7 characters of the SAH of a previous commit. For example, if the SAH of the previous commit is blah 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 blah, we will use the first 7 characters to reset it. Okay, so we do git log. I said git log. I said git log. There we go. From the terminal, enter the command to reset the previous commit, using the first 7 characters of one of the past commit SAHs in your git log. All right, so what if we do git reset, and we add this 1, 2, 3, 4, 5, 6, 7. Crap. Nine six F1 625. Okay, and check the git log again. And there's just 1 there. Okay. Git reset review. Better understand git reset commit SAH. Notice the diagram on the right. Each circle represents a commit. Head is the most recent commit. Head goes to a previously made commit. Okay, so essentially commits are like a node structure where it has a head and a tail. Except, yeah, we push to the head, so basically we're just resetting the head to something else and severing the connections. Okay. Generalizations. Congratulations, you've learned 3 different ways to backtrack in Git. You can use these skills to undo changes made in your Git project. So check out head, and reset commit SAH. SHA. What git command lets you view the SAHs of all previous commits? Log. In Git, the head commit is the code that runs before you check out a commit. The first commit deleted from repository, default commit made blah blah blah. Commit currently on. Why use git backtracking commands? To unstage a file from staging directory, all of these, discard changes in the working directory, all of these. Which command removes file changes from the staging area? Reset head. What git command gives you the output below? Staged changes after reset. So reset? You accidentally deleted lines from a file. Which command can undo your mistake? Control Z. Git add file name, git reset head, git checkout head. Yeah. Why use command below? Git checkout head to unstage the file from the staging area, to move head to the previous commit, to restore a file in the working directory to look as if it did in your last comment. Yes. Which statement is true about the command below? Git reset. The head will be reset to the commit whose SAH starts with yes. All right, more projects. All right. Before we do those, let's take the last break of the day. And when we come back, we'll finish the projects and whatever else we can. So see you in